Let's see the next application of divide and conquer, that is merge sort. Right, next application is merge sort. Right, now, and one more thing I want to say to you before going to the merge sort, please be careful, merge sort is really important. I never see any gate examination of CSE paper without having merge sort. It is really important, so that is the reason I used to cover each and every point. If you can learn properly merge sort, that indicates, right, you got algorithm subject. This merge sort contains so many things. It is very easy also, right, just follow from starting to ending, right. Otherwise you have to read many books also, I am really saying to you. Right, this is the one of the important topic in algorithm subject. After merge sort is over, next application is quick sort. Exactly same. If you know merge sort, you know quick sort also. These two sorting techniques are two powerful things in algorithm subject itself. If you get these two, you got algorithm subject. So if you want to get these two, first you should get the merge sort, then followed by quick sort. Please be careful. So I am starting. So if anyone know already merge sort, right, then also there is no problem, you can comfortably listen. Any new point is there, you take care. Whatever you know, right, I will say more than that. Please make sure that you follow. If anyone don't know, right, you no need to think little bit also negatively, right, concentrate from now onwards. I am starting. Topic name is merge sort. Topic name is merge sort. Can you help me now? To this merge sort, what is the input? Merge sort algorithm input is going to be everyone. It is the sorting algorithm. What is that one? An array. An array of n elements. Input is going to be an array of n elements. That is the input. Can you say what is the output? Sorted array. Sorted array of n elements. Input is going to be an array of n elements, output is going to be sorted array of n elements. That is the input and output. Right? I will explain one numerical example. Right? Input and output, if everyone is clear, let's go to the example. Please be careful from now onwards. One example, one numerical example. Just I am taking one array. I am saying to you, first I will explain anything I will explain normally with the numerical example, because many people are comfortable with the numerical example only. That is the reason, let me complete the numerical example. Array A, 1, 2, 3, 4, 5, 6, 7. Array A which contains 7 elements. So let me give the values also. I am giving the values also. Anything you can give, 50, 80, 20, 16, 13, 55, 35, some numbers. This is the array. I took one array which contains 7 elements. I want to apply merge sort algorithm on this. Right? Some people are asking, sir, how? Let me check. How to apply merge sort algorithm on this. So I am writing now, see this one. Can you help me now? On this array, if you want to apply merge sort algorithm, can you say merge sort is application of divide and conquer? First step what you have to say is when the problem is small. You have to say when the problem is small. You only say when the problem is small, you know very well, right? Small problem is less elements. You can take anything, right? Because of it is there in the syllabus. I am explaining clearly, those only you do. If new things will come, you can do whatever you want. Now I am explaining now, this problem is going to be a small problem, right? Please remember it, right? This problem is going to be a small problem if array contain one element. If array contain one element, small problem, right? I am writing here, see this one, small problem, one element. Right? So this problem, when you say divide and conquer, first step is going to be when the problem is small, right? This problem is going to be a small problem, one element is there. Please remember, new things, any new algorithm there, other than the things what I covered, if anything new will come, right? You take whatever number of elements you want. Maybe one element, maybe two, accordingly you have to behave. That is also right, these are also right? But anyhow, whatever is there in the syllabus, whatever way I will say, just follow like that. Right? Can you help me now? Merge sort is a small problem when? If array contain one element. Some people are asking me, if array contain one element, you are saying small problem, then what will be the solution? If array contain only one element, sorting of the array, that itself return that element. right? That is, I think that is a solution for that. One element, then solution is going to be that itself. Some people are asking, if array is big, what should I do? If array is big, find the mid element, like what have we done for the previous problem. Find mid element, right? Divide accordingly. Right? If I want to sort an element, see this one. If you want to sort an element using merge sort, what you have to do is, right? So if the problem is big, divide into two parts, right? N elements becomes n by 2, solve individual, afterwards combine it. Right? Everyone know that. I will explain that example. Right? I already took example also. Can you help in how you are dividing? Using mid. When you are dividing, mid is equal to I plus j by 2. Right? Like that you are dividing also. If at all fractions will come, take the floor value like this. So I think everything is ready. Now I am starting. Right? This numerical example using merge sort, how to sort, I will explain. See everyone now, I think everything fine. So let's start. See this one? Everyone have to listen, otherwise you may not get. If you don't get one point also, it will trouble you. Best thing is follow every point. Don't think negatively. So in my opinion, algorithm subject just started now because it's a major topic. Right, see this one. Array A which contain 1 to 7 elements, I want to sort. Array A which contain 1 to 7 element, I want to sort using merge sort. Can you help me now? Is it small problem or a big problem? Big problem. Why? Right? 7 elements are there. Some people are asking, how can you say 7 element? You know very well. First element index is 1, last element index is 7. Total elements are last one minus first one plus 1. 7 minus 1 plus 1. What is the answer? 7 elements. This array contains 7 elements, so this is not a small problem, it is a big problem. Then find mid element. What is the mid element? 1 plus 7, 8 by 2, 4. Mid element is 4. So what the merge sort will do? Just divide array A which contain 1 to 4 until mid. First half sort. Next one. Second half also sort. What is the second half? 4 plus 1, 5 to 7 sort. If you want to sort this array, because of it is a big problem, divide into two parts according to mid. First to sort both of them, then merge it. Now see, I am repeating now one nice keyword I am doing, just listen. This problem array A which contain 1 to 7, if I want to sort this, actually not possible because of it is not a small problem, it is a big problem. So what will you do? Divide the bigger problem into small sub problem. Yes. So solve the left half, solve the right half also after getting the sub problem solution. See this one. After getting sub problem solution, see this one. You have to combine. Combine, another name is going to be merge. You have to merge. Merge and combine same. But in the place of, instead of saying merge, instead of saying the combine, he is saying merge. Please be careful. Can you help me know what is the name of this topic? Name of this topic is merge sort. Name of this topic is merge sort. Right? Please be careful. Now, topic name is merge sort. Now, combine is called as merge. Merge algorithm means combine algorithm. Merge sort algorithm means total problem. Total problem name is merge sort. In that sub function is called as merge algorithm. Merge algorithm means, please remember, combine algorithm. Instead of saying merge, instead of saying combine algorithm, they are saying merge algorithm. In the previous problem they used to say combine, now they are saying merge. Please be careful. Merge sort different, merge algorithm different. Merge sort means sorting algorithm. Total problem is merge sort. But when you say merge algorithm, combine algorithm, please be careful. Right? Now see this one. It is a big problem, then divide. Solve the individual sub problem. Yes. Afterwards, combine it, means merge it. Some people are asking, if I want to merge it, right, these two required. First he required, do the same story, recursion. What is the answer? Is it big problem, small problem? Big problem. Then find mid element. What is the mid element? 1 plus 4, 5 by 2, 2.5. Take the 2 floor value. So array A which contain 1 to 2 sort. Array A which contain 3 to 4 sort. Similar way here also. Array A which contain 5 to 7 means how many? 7 minus 5. 7 minus 5 is going to be 2 plus 1, 3. 3 elements are there, big problem. Then what is the answer? Again divide. What is the answer? Array A which contain 5 plus 7, 12 by 2 means 6 there. So array A which contain 5 to 6. Next one, array A which contain, right, 7 to 7. 5 to 6. Next element is 6 plus 1, 7. 7 to 7. Right, like this. Next one. Array A which contain 1 to 2. Problem is a big problem. Divide. So what is the answer? If you divide it, the answer is going to be 1 plus 2. 3 by 2. 1.5 means take 1. Array A which contain 1 to 1. Next one, array A which contain 2 to 2. Next one, array A which contain 3 to 3. Like that you have to do. Array A which contain 4 to 4. Next one, array A which contain 5 to 5. Array A which contain 6 to 6. So like that. I am thinking that almost you are okay, right? Let's see the next story. Right, fine. I am thinking that everyone is comfortable. What is the next step? Can you help me now? Can you help me? In this particular tree, you only say who called first. This is called first. You know, already see this one. Already this story, right, we done previously. Again I am repeating now. Can you help me in this tree? Who called first? Everyone now. First person will call. It is the first function call. Can you help me now? It is the first function call. That is the reason I given C1. You only say to complete this C1 who required, right? To complete the C1 left required, right required. Both are over, then only C1 will be over. Parent is based on both the children, right? In both the children, which child will be complete first? Because both cannot be over at a time, right? One person will be complete. Who is that? Left first. Why left first is in the programming is the first person. In the tree left person is nothing but in the programming first person. In the programming it is the first line, it is the second line. First line over, then only second line. So after C1, this is called C2. Right? So after to complete this one it is required, but one thing recursion. To complete this one it is required. To complete this one it is required. But to complete this one no one required means it is over. Left over means then go right. It is the C5. Because of these 2 over, then parent over, then go here. It is going to be C6. This is going to be C7. This is going to be C8. These 2 over mean this is over. These 2 over mean this is over. This is over means then go here. What is the answer? C8. C8 already there. Sorry for that. What is the number here? C9. Because it's C8 there. C10. C11. C12. C13. Right, like that. To complete this one, this is required. To complete this one, this is required. To complete these 2, this is required. So, can you help me now? What is the order I given? This is called function calling sequence. I am writing also this one. This is called function calling sequence. Function calling sequence. Calling. Function calling sequence. Can you see what is the function calling sequence? Like this C1, C2, C3 and so on. What is the last one? I given the numbers like that. Last one is going to be C11, C12. I think C12. It is a function calling sequence, which is also called as pre-order. Which is also called as in the program in computer science terminology. It is called pre-order. Function calling sequence. Let me read. Fun means you may feel some other way. Function calling. Function calling sequence. Right? So in every programming language, function calling sequence is pre-order. Not only see this one, not only C language, not only Java language, in every language, function calling sequence is pre-order. What is the meaning of pre-order? First main will call. First main will call. After main call, right, inside the code if you see, whoever is there in the first place, he will call. Afterwards, second place, next one will call. Right, like that. First main, inside main, whoever is there inside. Assume that inside 5 function calls are there. Whichever is there first place, he will call. After first over, second will call. After second over, third, like that. First parent, afterwards left child, afterwards right child. Left child means first one, right? Right child means next one. Next one is going to be right child, right? Like that. This is called pre-order. Can you help me one small line now? In this tree, right? In this tree, you only say. In this tree, C1 call, C2 call, everything is fine now. Can you only say? You only say. In this tree, who will complete first? In this entire tree, who will complete first? Who will complete first? Who will complete? Can I complete C1? No. To complete C1, these 2 required. Can I complete C2? No. To complete C2, these 2 required. Can I complete C3? To complete C3, these 2 required. I think C4 will complete first. First C4 will complete. Can you help me? First C4, C4 over, then C5. C5 over, then C3. See this one. Both the children are over, then parent. See this one. Both the children are over, then parent. Both the children are over, then parent. This is called post order. Can you help me in this tree? Who will complete first to? C4. Next to C5. Next to C3. Because of this is over, then come here. To complete this, these 2 required. C7. Next to C8. Next to C6. Because of these 2 over, then C2. Because of left over, then go right. Right? To complete this, these 2. I think this is C11. Next one C12. Next one C10. Next one C13. Next one C9. Next one C1. This is going to be post order. Let me write now. This is called as function execution order. Let me write. Function execution order. Function execution order. Can you see what is the function execution order? Please see properly. First C4, next C5, then C3, next one C7, next one C8, next one C6, next C2. Right, after C2, what is the next one? C11, C12, C12, C10, next one C13, next C9, next after C9 C1. C1. This is called as post order. Post order means after children, parent. See, after children's only parent will come. These two children over, then parent. These two children over, then parent. This is called post order. Function execution order is post order. Function calling is pre order. Please be careful. Everyone know, only for namesake one time I explain. Next one, can you help me? What is the meaning of what is the meaning of merge sort? If the problem is big, divide. After getting both the sub problem, right, merge them or combine them, you will get the final answer. Like that everywhere going on. Merge these two, you will get this. Merge these two, you will get. Everyone, merge means combine. When you divided, you have to combine also. How many divisions are there? Those many combines will be there. Those many combines will be there, right? Now see this one. I am executing that numerical example, whatever I written on the board, right? I am executing that numerical example here, right? See this. See everyone, you know very well. You know very well. Just I have to explain one time. I am explaining. See this one. Can you help me one small? In this entire tree, who called first? You only say. In this entire tree, who called first? Who called first? C1. In this entire tree, C1 is called. That's okay. Can you see to complete C1, who required? C2 and C9. Then who required first? C2. C1 will call C2. C2 over, then C9. Means C2 required. To complete C2, who required? C3. To complete C3, who required? C4. To complete C4, anyone required or not required? Because of C4 is a small problem, one element. No one required. See this one, what is the meaning of calling? Who called first? C1. C1 called first means C1 will push first in the stack. After C1, C2 will push. After C2, C3 will push. After C3, C4. Some people are asking, why push happened? Function call means push. Why? To complete this one, this is required. Right? When you call this one, right? When you call this one, it will also push. Why? To complete this, it is required. When you say function call, push. When you say function over, pop. Can you help me now? Who is the top of the stack? C4. Top of the stack C4. Can you say, can you complete this one? Yes. Why? It is a small problem. Then complete. Then complete now. Because of you can complete, please can you complete this? I am completing now. Because of it is a small problem, I can complete. Can you help me now? What is the meaning of A11? Means only one element there. Only one element. What is the meaning of sorting? That itself. Only one element, sorting means that itself. So what is the answer? This is completed. Answer 50K. When you say it is completed, pop. When you say it is completed, pop. Can you help me now? To complete, who is the top of the stack? C3. Because it is popped out, C3. To complete C3, who required? C4 and C5. Because of C4 completed, then C5 required. Right? Because of C4 completed, C5 will call. Some people are asking, sir, how can you keep in the same slot? It is a free. Why can't I utilize? C3 called C4, because of it is completed, pop. Then again C3 will call C5, right? C5. Can say C5 is a small problem or a big problem? One element. It is a small problem. Directly you can solve. What is the answer? 80. 80. Right? This is 80. When you say it is completed, pop. And one more thing I want to ask, who is the top of the stack? C3. To complete C3, who required? Left required, right required. I think both are completed. Means both are available. Because of both the children are available, then parent will complete it. Now can you help me? How many people will go? Left one element, right one element. What is the meaning of merging? Means what is the meaning of combine? In this problem, combine is nothing but because of sorting. When you say combine, in this problem, merging or combine is nothing but left one element, right one element. After merging, two elements should come in sorted order. Left one person, right one person. After merging is over, two people should come in the sorted order. Can you help me now? 50, 80. After combining, two elements will come in sorted order. What is the meaning? 50, 80, sorted order. That indication that this is completed. When you say it is completed, it is popped out of the stack, which is nothing but these, right, these two things. Which is nothing but these two things will give answer 50, 80. Right? It's the current status. Same thing will continue further. Right? Some people are asking, until now, how much over, how much not over, how I know? Stack will say that. Stack will say how much over, how much not over. Can you only say, see the top of the stack. Top of the stack, who is there? C2 means here. Top of the stack, C2 there. Can you help me now? To complete C2, who required? To complete the C2, C3 required, C6 required. Is C3 over? Yes. To complete the C2, C3 required. Yes, completed. Next one. To complete the C2, C3 required, completed. Who is the next one required? C6 required. You will call C6. Can you help me now? To complete the C6, who required? C7, C8. Who required first? C7. C6 call C7. Because of it is gap, right? C7 will go here. Next one. Can you help me now? To complete C7, anyone required or no one required? No one required. Because of it is small problem, directly you can call. What is that one? A33. Who is that A33? Third element? 20. When you say it is completed, cancel. It is the 20 will come. Can you help me to complete C6? Who is the top of the stack? C6. To complete C6, who required? C7 also, C8 also. C7 over. Now C8. Can you say C8 is a small problem or a big problem? Small problem. A44. What is the answer? 16. Right? This is also cancelled. 16. Now can you help me with the top of the stack? C6. To complete this, both required. I think both are available. Now you have to merge them. What is the meaning of merging? Combining. When you say combine, 1 becomes 2 in sorted order. 16 and 20. 16 and 20. Right? Then C6 will be completed. Which is nothing but this is combined. 16 and 20. It is combined. Right? I am thinking that everyone is fine. Now you please help me. Some students are asking, sir, how I know? Until now, how much over, how much not over? That is the reason stack there. If stack not there, no one knows how much over, how much not over. Stack will say how much over, how much not over. What is the reason? Top of the stack, whatever there. Right? That story only over. Let's see. Who is the top of the stack? C2. Top of the stack C2 means, right? Now you are at C2. Can you say? To complete C2, right? Who is required? To complete C2, C3 required, C6 required. I think both are available. Yes. If both are available, now you can combine. You can merge it. So to complete this one, both the children required, both are available, right? You can merge it. Can you help me now? Left how many? 2. Right how many? 2. 2 plus 2, 4. 4 in sorted order. What is the answer? 16, 20, 50, 80. Right? This is completed. When you say you cancel this one, means it is popped out of the stack, which is nothing but these values will become how much? Right? Let me combine it. 16, 20, 50, 80, right? Like this. Like this, I done the combine, right? This one and this one, I done the combine. This is the story. Now, can you help me now? So, whatever you got until now, it is fine now. Now, see the next story. See the next story. Can you help me with the top of the stack? Stack will say everything. Can you see in the stack, who is the top of the stack? C1. To complete C1, who required? C2 and C9. I think C2 over. Now, it will call C9. Next one, to complete C9, who required? C10 and C13. Who required? C10. Try to remember, parent and child differ by one level. Right? All siblings will be in the same level. All siblings will be in the same level. Parent and child differ by one level. Right? After parent, child will come. So, parent level is 2, assume. Child level is 3. Right? Like that. Parent and child differ by one level. Siblings will be in the same level. Can you help me now? To complete C9, who required? C10, C13. First, C10 required. To complete C10, who required? C11. Can you say to complete C11, anyone required or no one required? No one required. Directly you can do. What is A55? What is the answer? 13. Right? It will become 13. Can you help me now? What is the A66? What is that one? 55. It is 55. So, what is the number? I think C12. C11 over, then C12 will come. C12 also completed. Means like this. Now, when you complete it, can you help me? Left and right both are available. You can merge it. So, what is the answer? 13 and 55. 1355. It will become 1355. Right? Fine. So, these two cancel mean this is cancelled. C10 over. Can you help me? Who is the top of the stack? C9. To complete C9, who required? C10 and C13. C10, C13. I think C10 over. Next one, it will call C13. To complete C13, who required? No one. So, directly you can do. What is that? A77, 35. It will become 35. Next one, can you help me now? Who is the top of the stack? C9. To complete C9, who required? Left required, right required. Both are available. Now, combine it. What is the answer? Left 2, right 1, totally 3 in sorted order. 13, 35, 55. 13, 35, 55, right, like that. So then C9 also cancel. Now I think it's the right, it's the correct time to ask you, please help me, it's the correct time to ask you, who is the top of the stack? It's the correct time to ask you, right, let me adjust first. Yeah, it's the correct time to ask you, who is the top of the stack? C1, top of the stack C1. Can you say to complete C1 who required? Left required, right required? I think left available, right also available, so you have to merge it. Now can you help me? I am doing merging here, but am I doing merge now only or many times? Many times I done merge here also. I done merge here also. How many times you divided? Those many times you have to do merge. Can you say top of the stack C1? To complete C1 who required? Both the children, they are already completed. Now I have to do merge. Can you say left how many? 4. Right how many? 3. After merging how many? 7 in sorted order. Can you say the sorted order? All these 7 elements. What is the answer? 13, 16, 20, 35, 50, 55 and 80. Right, total, I think total is 7 element, please check. All should come in sorted order, right, fine. So then I can say C1 completed, right. Then when you merge this one and this one, when you merge it, right, you will get this answer. After merging you got this answer. This is called as merge sort, everyone know this. Check properly, it is a stack, right, this is the tree. Can you help me one small, how many people will go? Inside computer, tree there, stack there. Inside the computer, tree is available or stack is available? Stack only available. Whenever recursive program is running, right, inside stack they are running. Inside stack they are running. What is the meaning? This is there. Right, inside computer stack only there. Some people are asking then what is the tree? Everyone know this stack. Listen, this stack, if you rotate with 180 degrees, this stack if you rotate with 180 degrees, tree will come. Right, both will be same. Stack is equal to tree only, both are same. This tree if you rotate with 180 degrees, right, 180 degrees if you rotate, right, root becomes last person. See, I think this is. Meaning wise both are same, right. Who called first in this entire diagram? C1. Who complete first to? C4. After C4, C5, these two over, then this one, something like that. You know, function calling sequence, you know, this is the function calling sequence. Function execution order also you know. Execution is post order, calling is pre order. And one more, this tree stack both are same. This is for user, tree is for user, right? Users are very happy with the tree. Computer is happy with the stack, right? So same stack in the form of tree I explained. Right, both will be similar. And one more, whatever is going on, I shown in the form of array also. Same thing, this is for computer, this is for you, only for namesake I explained this also. Right, I think wherever that one, see C11, what is the meaning? I think first one will be done, next one will be done, same thing I rounded. The same thing, see the rounds, all the things whatever I done, if you see, if you draw in the form of a tree, you will get that. See, I think it is the first one. It is the next one, afterward this one, right, in the form of it is the first one, it is the second one, afterwards this. Same way, it is the first one, it is the second one, right, afterwards this. So all three will be indirectly, directly same. If anyone thinking that, sir, I got one of them in all the three models, stack also, tree also, array also. These three, if you get any one, you got the total story. You got the total story. Whatever you done, previous problems also similar. In the previous problem, binary search, one side only you are going, but here both the sides. Both the sides you have to do. In binary search, only one side you have to go, but here both the side. In finding maximum minimum also, both the sides you are going. While doing finding maximum minimum, right? Same thing I done, same thing I explained. If anyone not okay that time, now you go back and verify. Now almost you got the full clarity. And tree and stack both are same. Stack if you rotate with 180 degrees you will get the tree. Now I think it is the correct time to ask you, please help me now. Recursive program stack space based on. Recursive program stack space based on number of levels in the tree. Not the number of function call. Number of levels in the tree. What is the reason? For every level one stack unit is enough. For every level one stack unit. If you want you can check, see this one. See first level, right? See this is the first level, one stack unit. Next one, second level, one more stack unit. Next one, third level, one more stack unit. Fourth level, right, one more stack unit. So 4 levels are there, 4 stack units. But number of function calls are 12, but stack units are 4 only. What is the reason? All siblings will use same slot. Why? Siblings will come one after another. First T will come, afterward this one will come. Right? Afterward C will go, like that it is going on. Recursive program stack space based on number of levels in the recursive tree. Please be careful. Right? You know function calling, you know function execution order also you know. Right? Recursive program stack space is number of levels you know. Right? See, initially when I started the recursion, that time you don't know anything. After listening to applications, almost you are okay. Now you got more clarity. Now can you say what I explained until now? Right? Merge sort algorithm, numerical example I explained. Right? 3 ways I explained. Tree also okay. Right? This is the tree. Same thing in the form of stack also okay. Same thing in the form of array also okay. Array, tree, stack, everything is same. Right? Everything is same. And one more. What is the name of the combine here? Name of the combine, they kept the name as merge. But total problem name is merge sort. Right? Please be careful. I hope everyone know. Oh, it's the correct time to ask you. I am thinking that you may be confused. Right? It's the correct time to ask you. Please help me. Please help me. Merge algorithm. I am not asking merge sort. Merge algorithm input. If you really got, please help me. What is the merge algorithm input? Not merge sort algorithm input, merge algorithm input. Merge algorithm input is going to be, merge means combine, merge algorithm input is going to be 2 sorted subarrays. Left one is sorted, right one is sorted, then you have to merge. Merge algorithm input is going to be 2 sorted subarrays. Output is going to be 1 sorted subarray. But merge sort if you see one array, this is the merge sort. If you see the merge sort, an array of n elements is the input, output is sorted array. But when you see merge algorithm, say this one, left half is completed, right half is completed, means you have 2 sorted subarrays. When you combine them, you will get the final one. This is called merge algorithm. So I think numerical example you are really comfortable. I am thinking that you are okay. And one more question I want to ask you. Please listen. What is the stack space you got? What is the stack space you got? I think 4 levels you got. 4 level stack you got. And one more thing. Stack space is going to be 4 units. It's okay. Let me write now. 4 units. Stack space is going to be 4 units. It's okay. Right? Can you help me how 4 units came? You know very well. Always you are dividing by 2. What is the meaning of finding mid element? See this one. Finding mid element means always dividing by 2, by 2, by 2, by 2. Left half, right half, left half. Always divide by 2, by 2, left half, right half, like that. Right? So that is the reason it came in terms of log n base 2. So stack space is going to be big O of log n base 2. 4 units. Don't see small mathematical calculation. Don't do that. Just see the logic. Okay, always I am dividing by 2, by 2, by 2, by 2. That is the reason log n stack space required. In merge sort, if anyone asks you from today onwards, stack space, what will you say? Number of levels in the recursive tree. They will immediately ask you how many levels are there. Because of logic is always divided by 2, by 2, by 2, log n level tree will come. So log n stack space. Right? Please be careful. I am thinking almost whatever is necessary you done. Can you say when the problem is small, 1 element. How will you divide mid element? Next one, what is the meaning of merging, combining? Can you say merge algorithm input 2 sorted subarrays, output final one is sorted. Can you see in this diagram, are you dividing one time or many times? Many times dividing. See, here divided, here also divided, here also. See, at every internal node there is a division. This is the internal node. Internal node means the node which contains children, right? This is the internal node. This is also internal node. This is also internal node. This is also internal. Every internal node. How many internal nodes are there? Those many divisions are there. But one thing, how many divisions are there? Those many combines are there. Every time division happen, combine should happen, guarantee. Right? I hope you are okay. Now let's go to the next one now. Right? Let's go to the next one. See the next one now. Don't confuse. See the next one. It is a very, very important one. See, please see carefully here. Next one. Merge algorithm. Next one is going to be merge algorithm. Please be careful. It is not a merge sort, it is a merge algorithm. Can you help me now? What is the meaning of merging? Combining, right? So because of inside the merge sort you are using merge algorithm. That is the reason this sorting technique name is given as merge sort. Inside this sorting technique you are using merge algorithm. That is the reason this sorting technique is called as a merge sort. Please be careful. What is the merge algorithm? Within few minutes I will explain. What is the merge algorithm? Within few minutes I will explain. Please listen this also. In total merge sort, major one this only. In total merge sort, major one this only. Some people are asking, sir, how? How it is a major one? What is the reason? You know division. Mid is equal to I plus j by 2. Divide, you know, like previous problem. You know small problem, one element. Right? The only difference between previous problem, this problem. Division is also same. Right? Small also same almost. Right? Only thing is combined differ. In this particular algorithm, major one is going to be merge algorithm. Right? I am starting now. Please be careful. All the questions in GATE examination from the merge sort, indirectly, directly based on merge algorithm. Please be careful. I am starting. Merge algorithm. See this one, merge algorithm input. 2 sorted subarrays. Merge algorithm input is going to be 2 sorted subarrays. Let me write. 2 sorted subarrays is the input to the merge algorithm. Array name is A. In this array A, until first half, first sorted subarray there. Second half, second sorted subarray there. Array name is A. In this array, first half contain first sorted subarray, second half contain second sorted subarray, because everyone know merge algorithm required 2 sorted subarrays. This should be sorted, this should be sorted. 2 sorted subarrays required. Let me take here 10, 20, 30, 40. If you want, you can check it is a sorted subarray. Next one, it is also required sorted subarray. Let me take here 11, 21, 31. Some numbers I required, I given. Right, also sorted subarray. I need for this problem merge algorithm 2 sorted subarrays required. Yes. First half is sorted from where to where? 1 to 4. Second half also sorted from where to where? 5 to 8. First one sorted, second one sorted, then I think because of 2 sorted subarrays are there, I can apply merge algorithm. I am applying now. Listen, I am applying. Can you help? Left how many people? 4. Right how many people? 4. After merging, how many will come? 8. So after merging, 8 elements will come. Then what I will do is, I will take one more array with 8 slots. Because to keep the result, left contain 4, right contain 4. After merging, 8 elements will come in sorted order. So let me take one more array. Name is called B array, which contain 8 slots. 1, 2, 3, 4, 5, 6, 7, 8. This array name is B, which contain 8 slots. Right? You have to do merge. Let me do the merge. So I am doing the merging now. Please carefully listen. Can you help me? Whenever merging is going on, here 4. When you merge, 8 elements should come in the sorted order. Can you help me now? If 8 elements coming in the sorted order, it's okay. Can you help me now? To this place purpose, how many people are fighting? To this place purpose, right? 4, totally 8 should come in the sorted order, right? Here sorted order should come. Can you help me now? To this place purpose, how many people fighting? What is the answer? Because of it is sorted, it is also sorted. Individually sorted. See, this is sorted, right? I want to make total as sorted. Right, the people who are fighting for this place is going to be, can you help me now? In the left group, who is the smaller? 10. In the right group, who is the smaller? 11. These 2 people are fighting. Other people cannot fight because it is a sorted array. He only can fight. Because from this group smaller, in these 2 smaller, 1 small will come to here. Right? Because it is a sorted array. Can you help me now? 10, 11, compare. 10, 11, compare. Who is the winner? Whichever smaller, he will come. Right? 10 is came here. Whoever smaller, he will come. 10 is came here. When you say he came, cancel it. Similarly, continue the same story. Every time from both the group, first person will fight. See this one, the person who can come next here is going to be, in both the groups, first person can fight. Can you say? First group, first person, 20. Second group, first person, 11. Whoever is smaller, he will come. Who is that? 11. Every time compare, whoever is smaller, he will come. Again now, who is the next person going to come? First elements only will fight. Who are those? 20, 21, best one, 20. Next, 30, 21, winner, 21. Next, 30, 31, right, winner. Who is that? 30. Whoever smaller, he will come. Like that. Every time first person only will fight. 40, 31. Who is the winner? 31. Like that every time smaller is coming. Next. 40, 41. Who is the winner? Smaller one. Who is that? 40. Right, like that. Can you help me once more? Like that every time. Compare, right? First persons are compare, both the first persons you take, compare, whoever smaller take in the answer. Whoever smaller take in the answer. Can you help me now? In the next time if you observe, can you say from the first group who is coming? No one. Right? If at all no one is coming from the, right, one group is completed, in the remaining group whatever elements are there, directly copy. What is the reason? It is already sorted. See this one. If both the groups are fighting, then you have to compare, right? One group is saying that my elements are not there. So another group, whatever elements are left out, you copy all of them because it is already sorted. The left out elements are already sorted. You no need to compare anyone. Directly store. Directly store. So for the last element, there is no comparison because first group elements are completed. Second group want to compare, but no one there. He will store directly. See this one, for every person one comparison required. Every person, can you say left how many people? 4. Right how many people? 4. Total how many? 8. 8 people there, every time comparison. See, for every element comparison required. For the last one no comparison. So what is the meaning? Totally 8 element, 7 elements, 7 comparison. For the last element there is no comparison. Total how many comparisons are there? 4 plus 4, 8 minus 1 because for the last person no comparison is there. Right? Fine. I am thinking that you are almost okay. What is the name of this algorithm going on? Merge algorithm. Merge algorithm input 2 sorted subarrays. Output, I think both the things you add. How many elements are there? Those many slots, one more array you take. Whichever smaller keep there. Whichever smaller keep there. One group is over. Next group elements copy directly. Right, like this. I am thinking that you are absolutely fine. Right? Now can you help me one small and just I am asking you, entire story whatever we discussed so far. Entire story whatever we discussed so far. Please help me. Right? Comparisons how many until now? Whatever you understood. Comparisons how many? How many comparisons? Let's say you know very well. Left how many? 4. Right how many? 4. Left 4, right 4. How many comparison? 4 plus 4 minus 1. Which will goes to 7. These many comparisons. If I want to say in the normal English line, what is the answer? N by 2 there. How many comparison? N by 2 plus N by 2 minus 1. Because for the last one, no comparison. N minus 1. Next one, in the similar way, Mn elements are there. What is the meaning of Mn? Unequal. Mn elements are there. Can you see how many comparison? M plus N minus 1. For the last person, no comparison. So these many comparisons are there. Please be careful. Next one more thing is there. Please listen. If anyone having small doubt also, within few minutes you will get clarity. Don't worry. Right? See this one. So 4, I think this is the story what happened. Based on this story, right? I written this. Number of comparison. Left 4, right 4. Totally 7. N by 2, N minus 1. M and N, M plus N minus 1. These are comparison. Now see one more interesting line. These are comparison. It's okay. See the one more thing. Moves, right? How many moves? What is the meaning of this? I will explain. See this one. Now, see this one. Whenever merging is going on, right? Whoever is winner, you are moving to the B or not? Whenever merging is going on, you are moving whoever is winner. In the A array, first element of both the groups, compare whichever smaller, keep that person in the B array, resultant array. Means you are moving element from A to B. You are moving element from A to B. This is called move, which is also called assignment. What is the meaning? B of I is equal to A of J, something like that. A elements you are storing in B, right? Assignment, which is also called as move. Can you help me one small line now? Right? Left 4 elements are there, right 4 elements are there, right? How many moves required? I think everyone now. Left 4, right 4. Right? While comparing, whoever smaller keep first. But whenever one group is over, remaining elements also store. What is the meaning? Moves should be 4 plus 4, 8. Everyone should move. One also you cannot leave. Comparisons may be for the last person not required. But one thing, this element also should move in the result. Move is going to be left 4, right 4. Moves are going to be, all elements should move to B array. Can you help me now? How many moves? Let me check. Left 4 there, right 4 there. How many? 8. Next one. Left N by 2, right N by 2. How many moves there? N. N by 2 plus N by 2, N. Next one. Left M there, right N there. How many moves? M plus N. These are the moves. Right? Merge algorithm is going on. These many comparison, these many moves. Now how many people will go? Please help me. Please help me. These many comparison, these many moves. Whenever merge algorithm is going on, compare, move, like that. Merge algorithm is going on. What is the meaning? You will compare and whichever is the winner, you move. Compare, whoever is the winner, move. What is the meaning? Comparison and moves only going on. So time complexity of merge algorithm is nothing but these two. Comparison plus moves. Whatever work is going on, that work only time complexity. Right? You know very well. So time complexity of merge algorithm, comparison plus moves. Right? These two things if you add, right, then time complexity will come. But one thing is true. Even though these two things you will add, that is called time complexity, it's okay. Even though if you add, right, who is the dominator? Comparisons and moves. Who is bigger? Moves bigger. Because in this one, some elements may compare, may not compare, but here everything you have to move, right? What is the meaning of time complexity? Time complexity means actually both you have to add, even though if you add, whichever is the dominator, right? Whichever is the bigger, he will dominate. Who is that? Moves. Time complexity is moves only. Right? What are the moves here? Let me write the same moves once again. What is the answer? 4 and 4. Moves how many? 8. Next one, n by 2, n by 2. How many moves? N. Right, next one, m and n. How many moves? M plus n. If you want, I will write these also, big O of n. So, time complexity of merge algorithm. Right, left m people, right n people. Merge algorithm time everything should move, m plus n. Left half, right half, n. Just add them, n will come. So, time complexity of merge algorithm is moves only. Please be careful. I explained clearly to you the reason. Some people are asking, sir, you explained very clearly. Some people are saying that merge algorithm you are explaining that much clearly. What is the reason? The reason is in the previous paper many questions are there. I struggled a lot, right? That is the reason. When you struggle, right, you will do lot of work. When you do lot of work, efficiency will come, right? That is the reason it came. If anyone thinking that, sir, I am explaining, sir, you are explaining merge sort and merge algorithm very clearly. What is the reason? The reason is previous paper many questions are there. If I want to explain clearly, I have to explain this much clearly. Right? To explain all these things clearly, I studied so many books again and again. So some efficiency came. Right? Please be careful. I am thinking merge algorithm absolutely fine. What is the merge algorithm time complexity? M people, n people, m plus n. Or n by 2, n by 2, n by 2 plus n by 2. Simply everything in the A array, whatever elements are there, all you have to move to B array. Right? Please be careful. I am thinking that you are absolutely fine. Right? One more small point is pending. Please listen that also. Within few minutes I will clarify that. Right? Listen, one more small point is pending. See this also. See everyone. One more small point. What is that pending point? I will explain. Pending point I will explain. Let me explain here. See this. See the merge algorithm. One more small point pending. See this. Assume that it is the example 1. Merge algorithm, it is the example 1. Assume. Right? Let's see the one more example. Merge algorithm. Merge algorithm, example 2. So, array name is A. One, two, three, 4, 5, 6, 7, 8, 9 elements I took. Left one contains 6 elements. Please be careful. Merge algorithm almost you got 90% you got. One small line pending. If anyone thinking that, sir, in the merge algorithm some doubt is there. If anyone thinking in the merge algorithm I have some doubt. The reason is this point is pending. Let me cover that also. See this. So array name is A, which contain 2 parts. Left one is going to be 1 to 6. Right one is going to be 7 to 9. Right? So these many elements are there. Let me arrange the values. Let me arrange. 10, 20, 30, 40, 50, 60, 70, 80, 90. Right? Some elements. This is the left half, left element. These are the right elements. right? Can you help me? Left how many people? 6 people. Right how many people? 3 people. Total 6 plus 3, 9. So with 9 elements to keep the result, take one more array. Array name is B. To keep the result, take one more array with 9 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So I think everything is ready now. So I am starting the merge algorithm. You know very well, right? Let me do this. Right, I am doing. See this one. Let's start. Who can come to the first place? Both the first elements compare. What is the answer? 40, 10. Winner. 10. Whoever smaller, he will come. Next. Can you help me now? 40, 20. Who is the winner? 20. Whoever smaller, he will come. Next. 40, 30. Who is the winner? Whoever smaller, he will come. Next. What is the answer? Right, from the first group, who is fighting? 40. Second group, no one there. If no one there, everything will copy. 40, 50, 60, 70, 80, 90. For these people, no comparison at all. Copy everything. For these people, there is no comparison because one group is completed. Copy all of them. What is the answer? 40, 50, 60, 70, 80, 90. Right? So like this. Now let me ask you one small and see this one. Merge algorithm purpose. You only say. Merge algorithm purpose. Merge algorithm purpose. I explain 2 examples. See. Example 1, example. Let me minimize. Merge algorithm purpose. I explain 2 examples. This is the first example. This is the second example. You only say. 2 examples I explained to merge algorithm. Right? What is the thing you identified? You only say. What is the thing you identified? If you observe clearly in the first example, whenever merging is going on, right? If you observe clearly, result is going, see this one, result is going, right? While merging, one time from this group element is going, one time from this group element is going. See this one, first 10 came from this group, next 11 came from this group, next 20 came from this group, next 21 came from this group. What is the meaning? Elements are going alternatively. Whenever in the first example, whenever merging is going on, elements are coming from alternative group, right? So sometimes, right, first time is from the first group, second time from the second group, third time first group, fourth time, right, second group, like that, alternatively coming. Whenever alternatively coming, right, one group become empty after long time. If one group is over, you are stopping the algorithm. If one group, whenever one group is completed, means comparisons are stopped. When comparisons are stopped, what will you do? Elements whatever left out, you are copying. So in this first example, what happened is, because of alternative elements are coming from different group, one group become empty after long time. After long time, one group become empty because alternatively we are taking. But here if you observe, elements are coming, always elements are coming from alternative group or same group. Right? Always elements are coming from same group. Whenever elements are coming always from same group, right, that group will be over within few minutes. Right? Whenever elements are coming always from same group, right, then definitely within few minutes that group will be, right, completed. Remaining elements you can copy. What is the meaning? Here the goal is going to be within less time. I want to make one group empty. But here, I want to take more time to make one group as empty. That indicate first example for worst case, right? Second example for best case. Merging is going on. Elements are coming from alternative group. Means to make one group empty, it will take a lot of time. Means that is for worst case. Whenever merging is going on, elements are coming from same group. When you say same group, elements are coming from same group. When you say same group, because if elements are coming from same group, within less time that group is over, right? So that within less time we can finish this algorithm, right? This will goes to best case. This will goes to worst case. Merge algorithm best case is this. Merge algorithm worst case is this. Merge algorithm best case this. From now onwards, if anyone asks you, when the merge algorithm will give best case, what will you say? From today onwards, if anyone asks you, when merge algorithm will give best case, what will you say? Whenever merging is going on, elements are not coming from alternative group, elements are coming from same group. Try to remember. Whenever merging is going on, elements are not coming from alternative group, elements are coming from same group, not only same group, right? Same group, that is also small group. Elements are coming from same group, that is also small group. If you want, you can check. Here 6 elements are there, here 3 elements are there. So elements are coming always from same group, that is also small group, then less time. Here elements are coming from alternative group, then more time. Right? Suppose assume that elements are coming from same group, that is also first group, assume. See this one. So if you take alternatively, what happened? Right? If you take alternatively 6 plus 3, 9, 6 plus 3, 9 minus 1, what is the answer? 8 comparisons required. If you take same group, that is also small group, 3 only required. If you take same group, that is a large group, then 6 will come. Try to remember. So same group, that is not small if you take, that is not best case, that is not work, that may be average case, that is in between. Minimum is called best case, maximum is called this will give worst case, this will give best case. Now it is the correct time to ask you, merge algorithm will give best case when? What is the answer? Whenever merging is going on, elements are coming from same group, that is also small group. If at all small group is not coming, larger group is coming, that is not best case, because best means minimum, right? Can you say when the worst case will come? Whenever merging is going on, elements are coming from alternative groups, so that it will take more time, right? Like that. Example 1 for best case, example 2 for worst case. Now let me give the conclusions also. See the conclusion, interesting one. See the conclusion. To the story, example 2, whatever we done, to the story, please help me, comparison so many. One interesting thing there, please listen this also. Comparison so many. To the story, comparison so many. See the answer? See everyone now. Left 6 there, right, left 6 there. Let me remove this. Left 6 elements are there, right 3 elements are there. Can you help me? How many comparisons you are getting? 3. Right, if you are okay with this one, you only say this line. Left 4 there, right 4 there. How many? So one group only, that is also small group. If both are equal, take any one, no problem. Next one. Suppose they are different. Left m people, right n people. How many comparison? Minimum of m comma n. Minimum of m comma n. If at all both are equal, take any one. That's okay. If at all both are different, take smaller one. These many comparisons. If you are okay with that, see the interesting answer. Can I say how many moves? Interesting one. Can I say how many moves? You want this how many moves? See everyone now. Left 6 people there, right 3 people there. Can I say how many moves? Whether you compare or not, I don't know. Every element should move. From A group to B group, every element should be moved. Please be careful. Right? From A group to B group, every element should be moved. So can you help in how many moves? Right? 6 comma 3. How many moves? 6 plus 3. 9 moves required. Same way. What about n by 2, n by 2? N by 2, n by 2. What is the answer? N. What about m and n? M and n is going to be m plus n. Please be careful. Whether you compare or not, I don't know. See this one. Comparisons may be decreased, but moves will be same. Moves will be same. See this one. Comparisons may decrease. Moves will be like previous case, and moves will be more also. Depending. See, if you compare both of them, moves will be more. So now can you help me? What is the time complexity of merge algorithm in the best case? What is the answer? Time complexity means, right? Time complexity means whichever is taking more, that is. I think moves and comparisons. Who is taking more? Moves only. Time complexity is moves only. Time complexity moves only. Now see this one. What is the time complexity for worst case? Same. Because moves will be same in both the cases. Here also moves bigger, here also moves bigger, which is the larger. So time complexity that only. Right? Please be careful. See. Time complexity of merge algorithm. Moves only. Because moves are always bigger. Okay, why? How many moves will be there? From A to B, everything should be shifted. So m plus n or n. Right? Please be careful. And one more. Can you help me now? Am I given one example or two examples? Two examples for merge algorithm I given. See, two examples. Let me show clear. Two examples for merge algorithm I given. This is for, please help me now. This is for best case or worst case? First one, worst case. This is for worst case of merge algorithm. This is for best case of merge algorithm. It is the best case. It is the worst case of merge algorithm, it is the best case of merge algorithm. Time complexity in both the cases same. Why? Moves are same. Whether you compare or not, I don't know. Everything should be moved from A to B. So, A contain n elements, right? All will be moved to B array. B also contain n elements. So, time complexity n moves. Best case also same. Comparisons you can save. Worst case comparisons are m plus n minus 1. But best case comparisons are minimum of m comma n. But time complexity moves only, right? Both will be same time complexity, right? Fine. And one more interesting answer. See this one. One more interesting answer. Can you help me one small line now? Whenever this merging is going on, see the interesting answer. This also. Whenever this merging is going on, can you see where is the input? Whenever this merging is going on, where is the input? In the A array. But where is the output? In the B array. What is the meaning? Merging is going on. Input is there in the A array, right? Output is there in the B array. What is the meaning? While merging is going on, you are keeping the result in some other array. Means you are taking some space extra. That is the reason this merge algorithm is called as outplace merge algorithm. You are using some extra space. Input is there in the A array. Within the A, if you adjust to somehow, that is called as in-place merge algorithm. But instead of doing that, you are taking another array, in that you are keeping the result. That is the reason this merge algorithm is called as outplace merge algorithm. It is not in place, it is outplace. Why? Whenever merging is going on, one more array you are taking. Right? If you want, you can check here also. See this one more B array. So that is the reason I am saying it is a merge algorithm, but it is in place or outplace. Right? Outplace. It is outplace merge algorithm. Please be careful. One more array you are taking. Outplace merge algorithm best case. Outplace merge algorithm best case. Outplace merge algorithm worst case. Now from today onwards, if anyone asks you when the merge algorithm will give worst case, when the merge algorithm will give worst case, time complexity forget. When the merge algorithm will give worst case, what is that one? Elements are coming from alternative groups. Best case, elements are coming from same group, that is also small group. Next one, best case, worst case. Comparisons are changing or moves are changing? Comparisons only. Moves are always same. How many moves? A contain how many elements? All will be shifted to B array. So I think number of elements. Yeah, right. I think total elements are in the A array, n elements are there. All should move to B array. So time complexity is moves only because the comparisons moves are more. That is the reason. And one more. Whenever merging is going on, I am taking one more array, that is called B array, right, of size n. That is the reason this merge algorithm is called as outplace merge algorithm. Outplace merge algorithm. I am thinking that you are little bit okay. Let me give conclusion. If anyone thinking that, sir, I have some doubt and all, let me give conclusion. See the first conclusion about merge algorithm. First conclusion. Right, see this one, first conclusion. See, everyone listen, right? See this one. Merging. We are talking about outplace merging only. We are talking about outplace merging. See this one. Merging two sorted. This is the conclusion. Merging two sorted sub-arrays or arrays, whatever it may be. If you want, you can say arrays. Merging two sorted arrays, each of size m and n will take order of m plus n time. Merging two sorted arrays, whatever it may be, sub-arrays or whatever it may be. Merging two sorted arrays, each of size m and n will take order of m plus n time. Can you say which case it is? Every case. Because what is the meaning of time complexity? Whichever is larger, that is the time complexity. Which is larger? Moves. Moves are always m and n there, everything should come. Time complexity means the place where more who is the more? Comparisons are moves. How many moves? How many elements are there? Those many. So time complexity of merge algorithm of size m and n will take m plus n time. It is not m into n, m plus n time. And one more, it is in place or outplace. Please be careful, outplace. Outplace merging, please be careful. Because one more array we are taking, right, to merge it. I am thinking that you are little bit comfortable, right? Let's go one more interesting thing there. Let me explain that also. With this everything completed. This is the only note which you have to take care. Outplace merging of two sorted arrays, each of size m and n will take order of m plus n time, every case. It is not best case, it is not worst case, every case. But what about comparison? Time complexity means moves only. Will take each of size m and n will take order of m plus n time. Time means what? Moves only. Please be careful. Time means moves because moves are more. Can you say comparisons how many? Only for name's sake. Comparisons how many? Comparisons. Best case how many? Worst case how many? Best case how many? Worst case how many? Best case, can you explain? If you remember, m and n, best case comparison, what is the answer? Minimum of m comma n. Can you say worst case? M plus n minus 1. You know this very well. But moves are always m plus n. See, m plus n is bigger. Moves are always m plus n. Comparisons are one time is minimum of m comma n. One more time is m plus n minus 1. What is the meaning? Comparing the moves and the comparisons, right? Moves are always bigger. So that is the reason time complexity. Fine, that is okay. Everything is fine now. It is the outplace and everything is okay. But one small thing pending. See that also. See everyone. For the merging, 2 examples also I given. That is also okay. Because of you are using one more array, B array, that is the reason it became outplace. That is also I am okay. Right? See one more interesting thing. See everyone now. Otherwise let me write. See this one interesting one is coming. One more example I am giving. Please you take care this. One more example. See the example. Array name is A. One more example. Please be comfortable. The small thing which is pending also. Right? One more array. So I took one array A. Next one, see this one. One array I took, it's okay. The name is A array. Right? In the 2 groups are there. Because of merge algorithm I want to do. 2 groups I am taking. A contain 4 elements. B also contain 4 elements. Sorry. A first half contain 4 elements. Right? A second half also contain 4 elements. Merging purpose, one more example I am explaining. Please you take care. Merging purpose, one more example I am explaining. See this one. One more example for merging. So I took one array, name is called A, which contains size almost like 8 slots until first 4, first half, next 4, next half. Right? See this one. Elements also I have to adjust. I am adjusting now. See this one. Elements 50, 60, 70, 80. Everyone now. Merge algorithm input. What is that one? 2 sorted subarrays. Yes, first one is sorted. Second one also let me go. 10, 20, 30, 40. Merge algorithm input is going to be 2 sorted subarrays. Yes. Right? Both are individually sorted. I think everything is fine now. Now let me check. Listen. Listen now. Please be careful. One nice point is coming. Please be careful. Can you help me now? Right? From the first group, who is fighting? 50. From the second group, who is fighting? First person only can fight. From the first group, first person is fighting. From the second group, first person is fighting. Who is the winner? First group, first person is 50. Second group, first person is 10. Whoever is smaller is the winner. Who is the winner? 10. 10 is the winner. Now, can you help me one small line now? Winner is 10. Listen everyone. Winner is 10. So, I will take that 10. I will take that 10. Whoever is winner. I will keep in another array. I will keep in another array. If you take whichever smaller and if you keep in another array, it become outplace algorithm. But the question is going to be, can't I make in place? Can't I make in place? What is the meaning of in place? Can't I do something within that array only so that space will be saved? Right? So whichever is the winner, I will store in another array. That is very easy. That is very easy. Right? So because of that reason, outplace that algorithm becomes outplace. The next question is going to be in one batch, one student asked me, right? So after comparing whichever is smaller, you are storing in another array. Why don't you store in the same array so that you can save the space, so that you can say in place also, right? For that purpose I tried. Let me try now. Who is the winner? 10. So I have to keep within this array only. But one thing you remember. Merge algorithm input 2 sorted subarrays. 2 sorted subarrays. Merge algorithm input is 2 sorted subarrays. Please be careful. If you give one is sorted, another one is not sorted, merge algorithm I cannot apply. Even though if you apply, it will take more time. Please be careful. Merge algorithm input is 2 sorted subarrays. Please be careful. Right? But one thing, my goal here is I want to make in place. Means within the array I want to adjust. Right? Let me adjust now. Can you help me now? 50, 10. 50 and 10. Can you help me now? Best one, 10. 10 I have to keep within this array. so that this array becomes sorted. Can you help me one small line? What is the meaning? I think 10 should come to first place. Because if 10 is the minimum, it should come to first place. But already first place, right? 50 there. Result should come to here. Some people are saying what they are saying. You see this one. Because of 10 is the minimum, keep the 10 here. Right? Keep the 10 here. 50 keep here. Just swap it. Yes, I done that. So result I want to keep within the same array. So I kept the result. But this place already someone is there. So I shifted to that place. Right? 10 place 50 came, 50 place 10 came. But one thing, right? In this particular array now, this is part of output. This is part of output. Don't bother. Whichever is the small, keep in this area. Yes, I kept. Right? Now it is not part of input, it is a part of output. Can you help me now? Now, who are the inputs remaining? In the first group, these people are remaining. In the second group, these are remaining. Now can you help me now? So one element is already kept in the correct place, that is fine. Now if you see the input, two groups are there, first group, second group. Can you help me now? Is first group is sorted? Yes. Is second group is sorted? No. But when you swap it, right, the one which is there in the proper order, it may not be now in the proper order. There may be a unsorted behavior. So I want to save the space. So within the array I want to adjust. But when you are trying to adjust, right, I think the fundamental property changed. What is that one? Merge algorithm input is two sorted subarrays, right? First one is sorted, see. First one is sorted. Second one is not sorted, right? That is a problem which came. Some people are asking, first one is sorted, second one is not sorted. If you want to apply the merge algorithm, both should be sorted. Now some people are saying, then why don't you sort the second half? Let me sort now. After swapping, because of second one is not sorted, to apply the merge algorithm sorting required, let me check, right? See this one, how to check. One more thing, assume that here n by 2 elements are there, assume here also n by 2 elements are there, half, right? Can you help me now? After swapping is over, now because of it is not correct, I have to sort. How to sort, right? Because of all are correct, this person only not correct, I have to ask. This is asking this person, am I correct or not? No. Then swap it. What is the answer? 50 here, 20 here. Again he will ask, am I correct or not? He said no. 30 here, 50 here. Again he will ask, am I correct or not? No. Then 40 here, 50 here. Like that you have to swap. So can you help me one small line now? 50, 10, smaller is 10. So 10 will go to the first place. First place person will come to this plus first place. Because of that reason, second half is disturbed. To make it is alright. What is the answer? You have to compare with everyone like this. I think one scan. So can you help me now? How much time it will take? What is the answer? All the element you have to scan like this. I think n by 2. N by 2 comparisons you have to do. I think let's see the one more story. See everyone now. Now next competition. First group, first person, 60. Second group, first person, 20. Right? Can you help me? Winner, 20. So 20 will goes to, right, here. 20 will goes to here, right? 20 place 60 will go, right? 60 will be here. 20 place 60 will go, right? Now, see this one, because of two people, this is the part of the output. Now can you help me now? Left half, these two, sorted. Right half, these all. See this one, 60, 30, 40, 50, it is not sorted. Again you have to sort. How to sort? Compare. Because of you only wrong, everyone is right. Now he is a newly came, you only wrong, he will ask everyone. 60, 30, 30. Next one, 60, 40, 40. Next one, 60, 50, 50. Finally 60 here. So like that, one more scan. What is the answer? For second element also, n by 2. If you want, you can check for third element also, n by 2. It will continue. Can you help in how many times? N by 2 times, because left also contain n by 2. So for every element, right, n by 2. Like that n by 2 times. Can you say total? What is the answer? Total is going to be n by 2 into n by 2, which will goes to n square by 4, which will goes to big O of n square. These many comparisons required. Can you help me? It is in place algorithm or out place algorithm? Suppose this is right, left n by 2 people, right n by 2. Can you help me now? Left not n by 2, left m people, right n people. What is the total story? Mn, order of mn. So I think it is the correct time to ask you, please help me, merge algorithm time complexity, out place, what is the answer? M plus n, but in place, m into n. Merge algorithm time complexity, outplace n by 2 plus n by 2 if it is equal size, but here n by 2 into n by 2. Can you help you now? In place, outplace, which will take less space? In place will take less space because no other array. In place will take less space, okay, but it will take more time. You only say m into n is bigger or m plus n is bigger. M into n is far bigger. 10 plus 20, 30, but 10 into 20 is 200. That is the reason. That is the reason. See this one. Some students are asking me, outplace means more space. Outplace means more space. Why don't you decrease the space? To do that, I tried. But I got to know that time is more. Try to remember, whenever time is more coming, don't take. Because the time is more important. Nowadays, space is almost negligible. Space, I think if you see the space, cost is almost negligible. If you take the small cell phone also, which contain huge space. Older days maybe space is going to be costly and all. Nowadays, in small cell phone also a lot of space is available. So space is, right, space you have to consider, not at the cost of time. Please be careful. Times are equal, then go think about space. Times are huge change, then don't go for space. So in place algorithm is going to be m into n, outplace is m plus n. In place is going to be n by 2 into n by 2, outplace is going to be n by 2 plus n by 2. That is the reason. From now onwards, if anyone asks you, merge algorithm, which merge algorithm? Outplace. In place, if I don't say this one, you may say that why can't in place, right? When you try to decrease the space, cost is, right, time is increasing. I try to decrease the space, right, time is increasing. That is the reason we dropped it. Right, please be careful. So this is the outplace. Let me give all the things which are required. Let me give. So this is the example for, please give the answer. This is the example for in place merge algorithm or outplace merge algorithm? In place. In place merge algorithm. In place merge algorithm, time complexity. In place merge algorithm, time complexity. Right, what is the worst case? Worst case, I explained worst case. Best case may be less. Best case may be m plus n. I don't have any problem. Worst case I explained. In place algorithm, worst case is going to be, what is the answer? Right, m into n, or what is that one? N by 2, n by 2. But in the case of the outplace algorithm, every time m plus n. Every time n by 2 plus n by 2. Right? Now I think one more thing I want to say to you. Please listen. Please listen correctly. What is the meaning of in place algorithm? In place algorithm means what? In place algorithm means, right, within the inputs only, within the input space only, right, you have to sort. In place sorting algorithm means, right, within the input only, whatever input is there in the A array, within the A only you have to adjust. That is called, right, that is called in place. Maybe you are thinking that is the definition for in place. Try to remember, in place algorithm is nothing but, right, you can take some extra space, no problem. In place means, right, in place means you can take some extra space, you can take, right. It is not like you cannot take at all, you can take, right. You can take little bit of extra space, not more. You can take little bit of extra space. Some people are asking, little bit of extra means how much, right? Constant space you can take extra. 2 variables you can take. Without taking 1 or 2 variables, I cannot write the program. Right? I have some input, right? I want to write the program. Inside compulsory I have to take some variables. In place means what? I cannot space little bit also. You can take little bit. How much? You can take constant space extra. You can take log n space extra. You can take log n space extra also, but more than log n not allowed. More than log n space is not allowed. If anyone asks you from today onwards, when can I say a sorting algorithm is in place sorting algorithm? Then what will you say? Right, any sorting algorithm which will take log n space extra or less than log n space considered to be in place. More than log n, outplace. Merge sort is not in place, it is outplace. The reason is going to be you are taking right, more than log n space extra, n space extra you are taking. One more array, B array, n space. Right, more than log n space, if any sorting algorithm will take, that is considered to be outplace sorting algorithm. I am thinking that merge algorithm is your absolutely fine. Merge algorithm is your absolutely fine. Every case I covered. One pinpoint also I didn't left, because if I leave in the previous paper, that only there, it will trouble you. All the things whatever I said, please revise once. Right? Fine. I think everything is there on the board. Let me do one time all. Let me do all one time. Let me compress it. So this is the in place story. Right? See the out place. This is the, see this one. The first one is going to be, see, first one. If you see the first one, it is a numerical example. It is the first one is numerical example. See this one. It is the example what we done. First one is example, right? After getting the example, major thing in this example, major thing is merge algorithm. Then I started merge. See merge algorithm. It is merge algorithm, worst case story I explained. Merge algorithm, right? Best case. But one thing, both are for out place. Next one. This is the merge algorithm in place. If I don't say this one, some people will think that I will go for in place and I will go for the in place and I will prove that less space. Yes, you can prove, but time is increasing. Because of time is increasing, so I don't consider it. Right? So here time saving, so that is the reason people are going to out place only. Please be careful, whatever I explain to you, every point is important. They may ask you comparisons. Merge algorithm minimum comparison how many? Merge algorithm maximum comparison how many? Merge algorithm time complexity how much? In place time how much? Out place time how much? Everything they will ask. Right? Please be careful. Don't buy hard. Don't do anything. Meaningfully study 1 or 2 times. No need to revise any book also. This is more than enough. I hope you are fine with the merge algorithm. Right? Now let's go to the major algorithm. What is the major algorithm? Merge sort. On merge sort, I explained the one numerical example. In that, while explaining the numerical example, you got to know that, right? In that powerful one is merge algorithm. I explained A to Z of merge algorithm also. If you want, I will write the merge algorithm also. Right? I explained the merge algorithm total behavior. If you want, you can write the program for merge algorithm. That is okay. Right? If you want, I will write also. If needed, I will write that also. Let's concentrate on merge sort algorithm. Merge sort algorithm. What is the main topic name? Merge sort. Inside combine algorithm name is merge algorithm, which you know very well. Right? I am starting now. See this one. Merge sort algorithm I am writing. See everyone, all the basics are over. Please concentrate here. Merge sort algorithm. See this one, merge sort algorithm. Can you help me now? To this merge sort algorithm input array A which contain I to j elements. To this merge sort algorithm input is going to be, it is not merge algorithm, merge sort algorithm, please be careful. To this merge sort algorithm input is going to be array A which contain I to j elements. Array A which contain I to j elements. Next one, if I is equal to j, you know one element is there, small problem. If I is equal to j, return A of I, return that element. Only one element is there, that itself is answer. You know very well. Next one, big problem, you know very well, else part, else, right? Now see this one, else part. Small problem, this is the story you know very well. Big problem, see the answer, big problem, what is the first step? If array contain 20 elements, right? Big problem, according to this algorithm, find the mid element, you know, mid is equal to, what is that one? I plus j by 2. I plus j by 2. Right. So mid algorithm, mid element I find out. Next one. After finding mid element, what should I do now? So this is the case. Right. See this one. This is the case. This is the array. Problem is a big problem. What they done first step? Mid element find out. Yes, I find out. Next. See the next one. See everyone now. Next one. What is the name of this array? What is the name of this array? Everyone listen. Name of this array is A. Right. So A array. See this one. A array. Array A, capital or small doesn't matter. So name of this array is A, problem is a big problem, first to divide, yes I divided. Now see the next step. After division is over, see everyone now. So using merge sort, what is the name of this algorithm? Merge sort. Using merge sort recursive call, see this one. Using merge sort recursive call, array A which contain I to mid, right? These elements you sort first. Using recursion, right? Sort this half. When you say this function call completed, right? I think total answer is there here. It is sorted. When you say main function, this one is completed, then total is completed. This one is completed, total array is sorted. But when you say, right, total is not completed, only this is completed. Left half is successfully over. Some people are asking, sir, how left half will be over? Recursion will take, they will internally call, don't worry. Next one, see the next one. Using, again one more merge sort call. Using recursion on the right hand side, sort the right half also, A, mid plus 1, 2J. Right, using this call, when you say that second call over, this also sorted. Because of this one, division happened. Because of this one, left one sorted. Because of this one, right one also sorted. Now, can you help me now? What you have in your hand? Two sorted subarrays. From where to where? First half, I to mid. Second half, mid plus 1 to j. Now you have two sorted subarrays. It's the correct time to call merge algorithm. Call the merge algorithm. I am not calling merge sort, I am calling merge algorithm. Merge algorithm call. Can you say merge algorithm input? Two sorted subarrays. Can you say two sorted subarrays are where they are in the A array? In the A array they are, first group is going to be I to mid, second group is going to be mid plus 1 to j. Right, this is the merge algorithm. You know, some people are asking, sir, what is the merge algorithm? The things whatever we discussed until now, if you write in the form of a program, that is called merge algorithm. If you want, I will write also within few minutes. Assume that this merge algorithm is done, right? When you say this merge algorithm is completed, total array becomes sorted, total array sorted. Please be careful. Right, lastly, return A. This merge algorithm is over means you got the sorted array, then return the array, then problem is completed. So, end of the else part, end of the total program. So, this is going to be merge sort algorithm. Right? Let me minimize it. I done. So, it is a merge sort algorithm. It is a very simple algorithm. Can you say why this algorithm looking like very simple? In this major one, everything is whatever you know, that only. Everything is whatever you know, that only. Major one, this only. Which one is major? Merge algorithm is major. This is taken lot of time to discuss also. See, almost like 1.5 hours I explained merge algorithm. Merge algorithm is the powerful one in this entire story. That is the reason they kept the name as merge sort. And one more thing I want to ask you. Please help me if you remember. If you remember, please help me. Can you help me now? This merge algorithm, time complexity how much? If you remember, this merge algorithm time complexity how much? Because of it the mid. What is the meaning? Left half, right half. Because of mid element you are finding left half, right half. Means what is the meaning? Left also n by 2 people, right also n by 2 people. What is the merge algorithm? This merge algorithm, right? Time complexity. N by 2 plus n by 2. Which will goes to big O of n. What is the reason? It is a outplace merge algorithm. Outplace. In place means, right, more time. Space may be less, right? But more time. But outplace. What is the meaning? Space may be little bit more, but time is less, right? So, merge algorithm which is outplace, time complexity n by 2 plus n by 2, so n time, right? Please be careful. Because of inside this algorithm you are using someone which is outplace, right? Total algorithm becomes outplace, it is outplace. It is outplace merge sort. Please be careful. Sorting algorithms are two types. In place sorting algorithm, outplace sorting algorithm. Outplace sorting algorithm example, merge sort. From today onwards you remember, sorting algorithms are two types. In place sorting algorithm, outplace sorting algorithm. Outplace sorting algorithm, first example, merge sort. What is the definition for outplace? If any sorting algorithm will take more than log n space extra, more than log n space extra, that is called outplace. Right? So, merge algorithm time complexity n, you know very well, which we discussed until now, this only. Right? Fine. Now, see the next one. One more thing. Right? See this one. Finally, because of algorithm also you are comfortable. Next one is going to be time complexity finding. You have to analyze also. Space how much, time how much. We have to analyze. I am analyzing now. See this one. I am starting. Time complexity finding how? Let me explain. See this one. Tn is equal to. See this one. Recurrence relation. Let me write. Recurrence relation for a time. Recurrence relation for time complexity. I am writing. Tn is equal to time complexity of or a time of merge sort of n, not merge of n, merge sort of n. N elements array, merge sort algorithm will take time complexity Tn. Tn is equal to time of merge sort of n. Right? Fine. If you are okay with that, now see the answer. Then time complexity Tn is equal to. Then time complexity Tn is equal to. You only say. So what is the answer? You know, small problem. How much time? Constant. Constant time. If n is equal to 1. Right, next one. So if it is a big, what is the answer? N elements merge sort is Tn time. If you believe that is true, n by 2 elements merge sort is Tn by 2. N by 2 elements merge sort is Tn by 2. Right, like that. So because in the divide no loop is there. So time complexity constant. Next one. See the interesting answer. Next one. In the merge algorithm there is a loop. In the merge algorithm there is a loop. Time complexity n by 2 plus n by 2 n. If anyone say how, right? If you want I will write algorithm. Total procedure if you see left one, right one, you have to compare. Again next one, one loop is there. Right? Time complexity means loops only. Right? Here no loop, constant. Here loop is there inside because left elements, right elements you have to cover. Right? N by 2, n by 2. See, it is the left half, it is the right half. One loop is going on. Only one element is there, loops not required. Left n by 2. Right n by 2, one loop required. Right? So finally, so merge algorithm time complexity n. Let me write now. So divide time constant. Conquer 2t n by 2. Can you say combine? Order of n. If n is greater than 1, this is the story. Let me simplify. Let me simplify here. Tn is equal to, carefully listen, Tn is equal to 2tn by 2. Tn is equal to 2tn by 2. Can you help me? Because of time complexity, small minimization you can do. See this one, constant plus n. How much? N. Tn is equal to 2tn by 2 plus n. Now it is the correct time to ask you. Please listen. It is the correct time to ask you. What is this n? This is the reconciliation for time complexity of merge sort. Everyone know. This entire thing is reconciliation for time complexity of merge sort. It's okay. But what is this n? This n is the amount of time required for both divide and combine in the first level. In the first level. And one more thing, you know very well, there is a diagram also. There is a diagram also. How many level? 3k, log n level 3k. When I explained the numerical example first time, right? For this particular one, merge sort algorithm, when I explained the numerical example, you are able to see in the tree also, log n level, right? Log n level tree will be there, right? First level cost, divide and combine n. If you keep on doing substitution method, every level cost also you will get to know. Total cost will come. Let me do. So n is going to be divide time, combine time, first level. Let's see the second level also, 2 common. Right, 2t n by 2 by 2 n by 2 square plus n there n by 2 there n by 2 outside n is there, right? If you simplify, see this one, 2 square t n by 2 square plus 2 into n by 2 n plus n. See the interesting answer. First level cost is divide time, combine time n. Second level also divide time, combine time n. Means in every level same is coming. Series not coming, same is coming. This is going to be first level divide time, combine time. This is the second level divide time, combine time. If you want, you can check yourself. Third level also same thing will happen. Right? Divide time, combine time, one more n will come. 3 rounds if I do, this is the story. If I do, because of divide by 2 log n time. If you do log n time, what is the answer? It will become 2 power log n. It will become t n by 2 power log n plus n into log n. Every time is n like that log n time. Then it will goes to 2 power log n is n, right? This will become t of 1 plus, what is that one? N log n. Can you say what is one small line? What is this n log n? Big problem cost. Big problem cost. Every level cost you added, total big problem cost will come. What is this n into t of 1? Small problem. If you want, you can check. In the bottom of the tree, right? One numerical example, that is the reason I done. If you see the numerical example of this merge sort, right? If you see the last level, what is that one? I think n, see this one, 1 element, n sub problems are there. 1 element, n people are there in the last level, right? So n sub problem, each of size 1, I think size 1 will take constant time. Let me write now. N into constant. This is for small problems. N log n. This is for big problem. Then total cost will come. Total cost is going to be big O of n log n. Big O of n log n. And one more thing. See this one. Time complexity of this algorithm. What is the algorithm name? Merge sort. Time complexity of this algorithm is going to be n log n. Time complexity of this algorithm is n log n. And one more small question I want to ask you. In this algorithm, which is the powerful if or else? Can you help me now? In the else part, if I start, see this one. In the else part, if I start here, I will end here. Is there any chance of stopping in between? If you start here, you have to end here. In between, no chance of stopping. In between, if no chance of stopping, time complexity, best case, worst case, average case, all same. In between, you can stop. Then best case may differ. In between you can stop, worst case may be differ because of no stopping in between. So every case same. So time complexity of merge sort algorithm is going to be n log n every case. N log n every case. And one more, how many times you done this story? Log n time. It is a stack space. Stack space is this. So time complexity of merge sort, right? N log n every case, because in the else part in between you cannot stop. Right, reconciliation for time complexity 2tn by 2 plus n. Why this n? Amount of time required for both divide and combine. Divide constant, but combine is n. This is the first time, right? Divide combine time becomes n. Because if you see the first application, finding max min, divide also constant, combine also constant, totally constant, because divide also no loop. In the first algorithm, finding max min, divide also no loop, combine also no loop, constant. But if you see the second algorithm, power of an element, divide time constant, combine time also constant, no loop is there. If you want, you can verify. If you see the binary search, divide time constant, no combine at all, constant. But in this algorithm, if you observe, divide is constant, but combine one loop is there, merge algorithm, big story. So this is the first algorithm where combine, right, divide and combine combinedly n. Right, please be careful. So that is the reason merge algorithm to explain taken lot of time, because there is a loop inside. So time complexity of merge sort is n log n every case. Stack space is log n. Fine, let me see one more interesting line. See this one, let me write the conclusion. Merge sort algorithm time complexity. What is that one? Order of n log n. Which case? Every case. Next one, merge sort extra space. Merge sort extra space. Extra space, how much for merge sort? Right, see this one. Merge sort extra space, if you observe, this is the thing. Merge sort extra space is going to be whenever merge algorithm is going on. In merge algorithm, you are taken one B array of size n. Whenever extra space of the merge sort is going to be, whenever merge algorithm going on, in the B array, you are taking n space extra, and one more, because of recursion, stack required by 2 log n time, right? Stack space as usual will come, stack space log n. So overall if you observe, how much? N space extra space is n. Whenever extra space is more than log n, it will become a outplace. Because of extra space is more than log n, it became a outplace. That is the reason outplace, right? Because of n is there, it became a outplace algorithm. If it is a log n, right, it is not outplace. Extra space is more than log n. That is the reason it became outplace. Time complexity every case n log n. What is the reason? In the else part, no chance of stopping in between. If you want, you can check the binary search. In between you can stop. Best case 1 came. In the binary search, in between written there. Right, you can stop in between. So best case becomes 1. But if you see the power of an element, if you see the maximum minimum finding, so maximum minimum finding, power of an element, and this algorithm, in between you cannot stop. So every case same. Binary search algorithm, in between you can stop. Best case 1, worst and average case log n. And one more, stack space is log n because of recursion. Because in the merge algorithm, because of its outplace, n space you are taking extra. Please be careful. N space for the merge algorithm, stack space is log n, overall is n plus log n means n. Because of more than log n, outplace. Reconciliation also please remember. So divide constant, no loop. Combine loop is there n. 2 subproblem, because of you are dividing into 2 parts. 2 subproblem. Solve this. 2tn by 2. Next one, divide constant, combine is n. Totally n. So tn by 2 for the subproblem. Divide time is going to be constant, combine time is going to be n. Right? Overall becomes n. This is one level story. If you continue further, everywhere n is coming like that, log n time n log n. Small problem cost, big problem cost, n log n. If you want, I will write the merge algorithm also. Please see this merge algorithm, which you know very well. Merge algorithm I am writing. One loop is there. See how? Yeah, see, this is the merge algorithm. I written the merge algorithm for you. Whatever you knows that only, right? I am not done anything new. Whatever you knows that only. Let me explain now. Let me explain. Can you help me now? From where merge algorithm is called? From here. See this. From here, merge. Right? If you want, you can make large also. See, merge algorithm is called from here. Can you help me now? Merge algorithm is called from here. It's okay. Can you say what the first one? Array. It's okay. Right? See this one. I will goes to I. Next one. Mid will goes to mid. It's okay. Next one. Mid plus 1 is k. Mid plus 1 is k. Please be careful. J is j. Like that all parameters are passed. Merge algorithm input is going to be two sorted subarrays. First half is going to be I to mid. Second half is going to be k to j. First half is I to mid. Second half is going to be k to j. See this one. So I think first half, what is the starting one? I. First half starting is I. Can you help me now? Second half starting k. So loops are starting. Can you say first part is from where to where? I to mid. Second half is from where to where? K to j. K to j. Can you help me now? I value, supposition that, right? So I value 1, mid value 4. I value 1, mid value 4. So 1 less than 1 less than or equal to 4 or not? Yes. Suppose assume that whenever this algorithm is going on, I is increasing, I value becomes 2, 2 less than or equal to 4, I is increasing, 3 less than or equal to 4, I increasing, 4 less than or equal to 4, I increasing 5, then fail. Indication that first group is over. When I crosses mid, then first half is over. Next one, k value also sees one. Whenever this loop is going on, right, I is increasing, k also will increase sometimes. It is the k. K is increasing. So k is increasing. K value isn't that k value 5. J value 8 isn't that. 5 less than or equal to 8. 6 less than or equal to 8. 7 less than or equal to 8. 8 less than or equal to 8. 9 less than or equal to 8. Condition fail. Indication that second loop is over. Second half is over. First half not over means I less than or equal to mid true. Second half is not over. K less than or equal to J true. And listen everyone now. It is the end operation or R operation. End. What is the meaning? Both the halves not over. Then only you can compare. First half some elements are there. Second half some elements are there. Then only you can compare. So I less than or equal to mid true means first half some elements are there. Next one. K less than or equal to J true means second half also some elements are there. Means both the half elements are there. Both the half elements are there. And one more. First half which element I have to compare? First element. What is the meaning? AI. Second half which element I have to compare? First element. Who is that? AK. So AI, AK both compare. First half first element, second half first element compare. When you compare, you got to know that AI bigger. What is the meaning? First half first element is bigger. Means AK is smaller. Smaller. I want smaller one in the B array. Then what will you do? Smaller one means A of K. Store into B array. Result should go from A to B array. Right? So, see this one. Smaller, whichever is smaller. Who is smaller? AK. Second half first element is smaller. Store that one into B array. B array which place? At M is equal to 1. First place. So, B array, see this one. Second half first element because of is smaller. Store into B array first place. Because of you stored already this element. So, M plus plus K plus plus. Right? This is the while loop. Once again go back. Again check. Is it true or not? Because of element is going from here. K is increasing. Again check this condition, this condition. Again true. Means elements are there. Compare again. A is greater than AK. Means AK is smaller. Yes. Then again AK will store in the BM. Then M plus plus K plus plus. Suppose it is fail. What is the meaning? AI is smaller. Then BM contain AI. Then M plus plus I plus plus. This will continue until any one of the person is over. Means either first half over or second half over. Right? Then only this loop will stop. Suppose no one over. Continue. Suppose someone is over. Suppose that someone is over. Isn't that this condition fail? 0. Fail means 0. 0 and anything is 0. So out of the while loop. Whenever one group is over, automatically this while loop is fail, then you will come here. When you come here, what is that one? Remaining elements copy to B array. Suppose assume that first half completed out of while loop, then second half elements whichever is left out, copy to B array. Suppose assume that second half is completed, first half some elements left out, they will be copied to B array. Right? Remaining elements copy here. See this one. Whenever this loop is going on, comparisons are going on. Moves also going. This is a move. Whenever this loop is going on, comparisons are going on, moves also going on. But whenever this loop is over, then also moves are there. See, remaining elements copy to B array. So here also, see how many comparisons, those many moves there. Comparisons are not there, then also moves there. So moves are the time complexity of merge algorithm. Can you help me now? This merge algorithm time complexity, what is the answer? M elements in the first group, N elements in the second group. Here few comparisons are done, few moves. Whenever it is over, remaining moves will be here. Total moves are M plus N. So time complexity of merge algorithm M plus N, big O of. Suppose both are equal size, big O of N by 2 plus N by 2 because of moves, which is nothing but big O of N. You know time complexity, everything. This is the algorithm for this. This is the merge algorithm. Both the groups not over. Then compare first elements. Whichever smaller, keep in the B array. Right? Suppose one group is over. Remaining elements copy to B array. This is the merge algorithm. There is a, see, there is a loop. Loop is there, then only time complexity. See this one. Here divide. Divide step no loop. Constant time. But merge algorithm there is a loop. Right? How much time? M plus N. If both are unequal. If equal, N time. Because of these two are equal, N time. So this is the merge algorithm. Please be careful. It is a nice algorithm. It will be useful many places. That there is, I written the algorithm also. Fine. It is in place merge algorithm or out place? Because of B array, see, B array, B array. A array is input, B array you are taking of size n, it is going to be out place. Right? I am thinking that you are absolutely fine. So, powerful one is merge algorithm. No need to by heart. Can you help me? From now onwards, if anyone asks you, explain merge algorithm, what will you say? Two groups are there which are sorted. Both the first elements compare. Whichever smaller, keep in B array. Continue until one group is over. One group over, what about remaining elements of another group? Copy those elements to B array. Because of your copying means you are doing still moves. Here also moves done. Out also you done the moves. See, out of the loop also you done the moves. Total moves are these many. Can you help to this particular algorithm? Best case comparing so many. These are moves. These are moves. Everyone know this. Can you help comparing so many? To this algorithm, comparing so many best case. Best case minimum of m comma n. Can you say worst case? This is best case, it's okay. Worst case how much? No one will ask you average case. Please be careful. Can you help in a worst case? Worst case comparing so many. What is the answer? M plus n minus 1. In between is average. It is the minimum, it is the maximum, in between is average for comparison. But time complexity, it is the time. Time complexity means moves only. Let me write. Time complexity means moves only, which is going to be big O of n. I am thinking you are absolutely fine. Right? Anyone having any doubt, please take care. This is the main algorithm. Inside that sub algorithm merge, which is the powerful one. That is the reason it is called merge sort. Right? So extra space out place. Time complexity reconciliation 2t n by 2 plus n. N is the time for divide and combine every level. N log n time n log n. This kind of stack, see this one. This kind of tree will come. See this one. Divide, combine n time. Here how many elements are there? N by 2. Here n by 2. N elements n time. Similar way, n by 2, what is the answer? Divide, 2 parts. If you combine, n by 2 will come. N by 2 again 2 parts, n by 4, n by 4. If you combine, n by 2. Overall is n. 2 n by 2s. If you want you can check. 2 n by 2s. I am maximizing, I'll see. 2 n by 2, second level. That is the reason. Next one, same thing. Right? Next level if you observe, 4 n by 4s. Check yourself. 4 n by 4s will come, right? Everyone leads to 4 times n by 4 will leads to n again. Like that log n time. So if from now onwards, if anyone asks you time complexity of merge sort n log n y, what will you say? Always I am dividing by 2 by 2 by 2 by 2, log n level 3 will come. Right? Log n level 3 it's okay, but every level I am dividing also, I am combining also. Time complexity, every level divide time, combine time n. Like that log n time, n log n. Some people are asking, every level divide time, combine time, n how? What does that mean? Divide 1, but combine is n. Combine is n. That is the reason 1 plus n becomes n every level, like that log n time, n log n. So, lot of theory we done, right? Time complexity finding, many things we done, right, on merge sort algorithm, right? Let's see the problems also. How they will ask in the GATE examination on merge sort problems. Right? You can see those. Right? It is the first problem. Read it. Please be careful from now. Some people are saying that they will listen the total theoretical things whatever I said until now. Right? For the merge sort algorithm, they feel that they know everything about merge sort and all. If you know everything about merge sort, right? You should solve the problems also. It doesn't matter whether you know the theory or not. It doesn't matter. Are you able to solve finally problem or not? That really matters. So from this problem onwards, please be careful. I know that you got everything, but what is the proof that you got? What is the proof? You have to solve these problems. If you stuck at anywhere, I will help you, right? Let me start. Read the problem. How much time it will take to convert log n sorted subarrays each of size n by log n into single sorted array with n elements? This is the given problem. How much time it will take to convert log n sorted subarrays each of size n by log n into single sorted array with n elements? Means you want to say that he is having how many sorted subarrays? In this problem, he is having how many sorted subarrays? Log n sorted subarrays he is having. He have these many sorted subarrays, log n. each of size n by log n. These many groups are there which are sorted, these many sorted groups are there. Every group size is n by log n. Can you say total elements how many? Log n group where every group size is n by log n, total elements are n elements. Means what is the meaning? He is having log n groups. Every group contain n elements. Now finally what he want is, he don't want these many group. He want one group with all elements which are sorted. So now what he is asking is, to do that, how much time it will take? How much time this procedure will take? What is the procedure? Log n sorted subarrays, each of size n by log n, you want to make it as single array of size n which is sorted. Finally you want sorted array with one sorted array with n elements. Now log n sorted arrays. Finally you want one sorted array with n elements. How will you solve this problem? Right? So using merge sort, whatever theory you know, right? Based on that, how will you solve this problem? Right? Please check. You have to apply your knowledge, whatever you know, to solve this problem. So how will you do that? And one more thing I want to ask you, please say, how many groups you have? Log n group. Every group is sorted? Yes. You have so many sorted groups are there. You want to make it as single sorted group. Means what is the meaning? You have to do merge. Many are there, you want one. What is the meaning? You have to merge. So I think indirectly, directly is asking, do you know merge algorithm or not? Please be careful. From today onwards you remember. Input is more than one sorted subarray. Input is more than one sorted subarray. But output is one sorted array. Indirect signal is giving. Apply merge algorithm. Not merge sort. Input is more than one sorted subarray. Output is single sorted subarray. Single sorted array, then indirectly saying apply merge algorithm. Suppose input is one sorted array, then indirectly signal they are saying apply binary search. Input is one sorted array, indirect signal they are giving apply binary search. Input is more than one sorted subarray, indirect signal they are doing that apply merge algorithm. Right? I will do that. How to solve this problem? Right? I will do that. So until now I explained the problem. Right? Now I will give the answer how to solve this problem. Let's check here. See this. I am starting. See everyone now. Make sure that from now onwards, please be careful with this problem. See this. First group, second group, third group, fourth group, and so on. Fifth one, sixth one. Like that some groups are there. If you want, let me rotate. So can you help? First group, second group, third group, fourth group, and so on. Log n minus one group, log n group. These many groups are there. Next one. What are the every group size? Everyone is sorted. Please be careful. Everyone is sorted. N by log n element sorted. N by log n element sorted. Like that, every group contain n by log n. Right, like that. I hope everything is fine now. Now see this one. You know merge algorithm also, right? So let's see. Can you help me one small line? First group contain how many elements? N by log n. Second group contain how many elements? N by log n. Is it sorted? Yes. Is it sorted? Yes. Merge them. Because you want these many groups as single group, right? Let's do 2, 2. Let me merge 2, 2. So can you help me? Here n by log n, here n by log n. Can you say totally how many, if you merge them, how many will come? 2n by log n elements will come. Here n by log n, here n by log n. If you merge them, all elements should move. When you say all elements are moving, time complexity is moves only. How many elements came? That much time. Comparisons may be less, but moves only time complexity. N by log n, if you merge them, 2n by log n elements will come. Time complexity is moves only. How many elements are there? Those many moves, that itself is time complexity. This also same, merge them. 2n by log n. Right, like that, this also merge. 2n by log n. Right, like that. And one more small question I want to ask you. Please listen. Right, if you listen properly, please give answer. In this level, you only say, in this level, right, how many groups there? You only say. In this level, how many groups there? You know very well. How many groups in the bottom level? How many groups in the bottom level? Log n groups are there. If we make two groups as one group, right? How many groups become? Log n by 2. Log n by 2 groups again. Bottom level log n groups means if you make 2 as 1, log n by 2 groups will come. So in this level log n by 2 groups there. Can you help me one small line now? In this level log n by 2 groups there, it's okay. But to get every group, how much time? How many elements are there? That much time, because you done the merging here 2n by log n time, you done the merging here 2n by log n. Can you help me now? Log n by 2 merging side done, every merging will take 2n by log n time. How many mergings you done? How many groups are there? Those many. Log n by 2 merging side done, because 2 becomes 1. So log n by 2 people there means log n by 2 merging side done, every merging will take 2n by log n. So I think log n cancel, 2 cancel, how much? N. Right? N came. Some people are asking, sir, how n came? You know very well. Number of elements are n only. We already done. See this one. Log n groups, every group is n by log n. Total elements are n only. Total elements are n only. What is the meaning? In this level, n elements are there after merging. Right? Those n elements came here also. Previously they are in the bottom level. Now they came to next level. But the only difference, previously in log n groups those n elements are there. Now in the log n by 2 groups, right, those n elements came. Previously n elements are there in the log n group. Now after merging is over, right, those n elements are there in log n by 2 groups. What is the meaning? Groups are compressed. N elements are there previously in the log n group. Now n elements are there in the log n by 2 groups. Groups are compressed, but elements are same. Number of elements are same. N elements only there. Whether you keep the 20 group, 30 group, right? When you compress it, when you merge it, groups, number of groups may be decreasing, but elements are same, because you are moving from one level to another level. Okay, whatever you got until, I am thinking that you got little bit idea. Let's see the next story also. See this one. Again merge then 2. It will become 2n by log n, 2n by log n, 4n by log n. Right? This is also same. What is the answer? 4n by log n, like that. So can you help me? If you are really comfortable, what is the answer? Already here log n by 2, if you merge 2 as 1, same. Log n by 2 square groups are there. Every group contain 4n by log n. What do you mean? 2 square n by log n. I think log n cancel, 2 square cancel, again n. Can you help me now? First level, second level, same means, I think same thing coming, series not coming. First level, second level, same means same thing only will come, right? Series not coming, same is coming. Can you help me? If you guess properly, what may be the next one? Roughly, what may be the next one? Isn't there something like that? Roughly, can you help me now? 4n by log n, 4n by log n, 8n by log n. It is also 8n by log n. Say roughly say what is the answer? Right? Log n by 2 cube. Right? 8n by log n. Log n cancel, 8 cancel, n became. Right? Like that. You please give the answer to me. If you do 3 times log n by 2 cube, if you do 10 times log n by 2 power 10, can you help me one small line? Assume that I done this one k time. I done this one k time. You only say, if you do k time, what will happen? K times I done. 3 times if I do log n by 2 cube. 2 times if I do log n by 2 square. 1 time if I do log n by 2 power 1. K times. What is the answer? Forget about this. If you do k time, what is the answer? Log n by 2 power k. Right? Into. What is the answer? Same way. 2 power k n by, right, log n cancel, 2 power n, 2 power k cancel, finally n will there. That is also fine, right? So see this one, here 8 means here also 8, here 2 square means here also 2 square, here 2 power k means here also 2 power k. If I do k time log n by 2 power k into 2 power k n by log n cancel, 2k cancel, n. Some people are asking, after doing k time you stopped. What is the reason? Right? Here log n by 2 groups, here log n by 2 square group, here log n by 2 cube groups, here log n by 2 power k groups. Some people are asking, why you stopped? Log n by 2 power k becomes 1. It became one group. That is the reason I stopped. Some people are asking, after doing k time, this value becomes 1. How? Let's check here. See this. How many times you done? K times. I done k time. right? So can you, some people are asking, sir, what is the k value? Let me check. Log n by 2 power k is equal to 1. That is the reason I stopped. If at all it is not, lastly I want one group. Finally one group came. See, this became 1. This became one group, that is the reason I stopped. Can you see at this level how many group? Log n by 2 groups. Here log n by 2 square group. Groups are decreased. Finally log n by 2 power k groups are there, but I stopped it after doing k time. These many groups came, I stopped. Why? This became one group because I want single group, right? Let's check. Log n by 2 power k is equal to 1. Log n is equal to 2 power k. So finally log n is equal to k. K is log n. So what is the meaning? Number of levels are log n. These many levels are there. Every level cost is going to be n. Why this n? In every level merge time. In every level merge time. There is no need to divide here. We are not dividing here because already divided. Log n groups there. Log n sorted subarrays are there. I want to make it as single. What is the meaning? You have to merge. You no need to divide. You have to only combine. So every level merge time n. How many levels? Log n. So can you say final answer? N log n. Final answer is n log n. Right? Please be careful. Number of levels are log n. K value log n. Every level is n. Answer is going to be n log n. Now I think it is the correct time to ask. Let me minimize it. Please help me now. In this diagram, if you observe, are you dividing by 2 or not? In this diagram, let me say simply way. In this diagram, are you dividing by 2 or not? Yes, you are dividing by 2. If you divide by 2, log n will come. If you divide always by 2, log n will come. If you divide n always by 2, log n. If you divide a always by 2, log a. If you divide always log n by 2, log n. If you always divide log n, see this one, log n group, always dividing by 2. What you divide always by 2, then log of that will come. Because of you are dividing always log n by 2, log n. N divided by 2, log n. A divided by 2, log a. Log n divided by 2, log n. So log n levels are there. Every level merge time is n. Finally n log n. So to this problem, this done. Some people are asking, sir, you are merging 2, can't I merge 3? Yes, you can do. Then answer is going to be log n. See this one, number of levels become, because of you are always dividing by 3, log n base 3. Always if you divide by 3, log n base 3, right? Same way here, see this one. Log n by 3 power k is equal to 1. Log n is equal to 3 power k. So log n base 3 is equal to k. K value becomes log n base 3. Both differ by only constant. Right? Fine. I am thinking you are comfortable. To this problem, what is the answer? N log n. Why that log n? Log n levels there. Why? Always log n divided by 2. Then log n. Every level cost for merging n. Right? Fine. To this problem, answer is n log n. Can you help me now? Actual merge or time complexity? Actual merge or time complexity is n log n, but this particular algorithm time complexity n log n. Why? He already done some work. Some people are asking how he already done some work. What is this one? See this one. Log n sorted subarrays. How he got? He already done some work. That is the reason less time came. In the normal merge sort algorithm, if you observe, log n levels there, but here only log n levels. So in the normal one is log n level, here only log n. What is the meaning? Already this person done lot of work he done. Can you say already he done lot of work? What is the lot of work? Right? If you see this algorithm, see this one below in this area. In this area, right? Some part he already done. This part already he done. He done this part, right? Then he enter into this area. Can you help me here? How many groups there? In this problem, how many groups there which are already sorted? Log n, right? But in the normal merge sort algorithm, if you see this one, if you see normal merge sort algorithm, n groups there, where every group contain one element. N groups there in the normal merge sort. Every group contain one element. N groups there. In the normal merge sort algorithm, array is the input. In the normal merge sort algorithm, array is the input, not log n sorted subarrays as the input. Normal method sort, n elements array as input, which is nothing but, right, n sorted subarrays, each of size 1 as input. Now when you combine, then you will get this answer. So he already done some work. Because of he done already some work, time complexity less. In the normal method sort, starting to ending you have to do. If you do from here to top, see this one, from here to here. If you do from here to here, how many levels? If you do from here to here, log n level. Because of you are doing only this part, log n level, every level cost is n. It becomes n log n. If you do from here, then it could have been n log n. Only half part. So what I want to say indirectly, directly, if you know full answer, you have to give half answer also. You will ask whatever you want in this entire story. What you know, n groups to, see this one, n group, each group contain one element. See this one, this is n groups, see this one, n group, where every group contain one element. From this place to one group n elements. You know from starting to ending. But he can ask anywhere to anywhere. From where he is asking? He don't want n group each of one element, log n group each of n by log n. From here to here he want. In one gate examination he is asking starting to ending. In one more exam, right, from middle to here. In one more exam from here to here. Anything he can ask. Can he help you now? Normal method sort algorithm input. Normal method sort algorithm input. What is the input? One array of n element. Another way of saying the same thing. Array of n element is the input. Another way of saying is going to be n sorted subarrays, each of size 1 means n elements array. If I want to talk in this terminology, method sort algorithm input is going to be n sorted subarrays, each of size 1. Output, one single sorted array. So this is the starting, this is the ending. But in this problem, log n sorted subarrays, each of size n by log n. Finally, you want single sorted array. So in this entire diagram, you know this entire diagram. He is asking only few parts. That only how to give. Right? Please take care. Finally, can you help me now? For this problem, final answer, n log n. Comparing actual answer n log n, this is less. Why? Here less work. Because most of the work is done. Right? Fine. To this problem, answer is n log n. Right. Let's go to the next problem. See the next problem. See this. Almost similar. See the next problem. The reason why I explained the previous problem that much clearly, the major reason is going to be this only. Right? Similar kind of problem I given so that you can easily give answer. Let's check. How much time it will take to merge a sorted subarrays, each of size b, into single sorted array? How many sorted arrays? A. Each of size b into single sorted array. How? Right? I think same problem. The only thing is I changed the numbers. If anyone having small doubt also, let me do. A sorted subarrays, each of size b. Instead of using n and all, just used a and b. Let's check here. See this one, I am just roughly I am giving. Can you help me now? Roughly. Can you see how many groups? A group. See, first group, second group, third group, fourth group. Next one, A minus 1 group, A groups. Every group contain B elements. Right, now can you help me now? These are sorted or not? Yes, they are sorted. Now see this one, merge it. What is the answer? 2B. Merge it. 2B, like that, all 2B like that. Can you help me in this level? Please, this problem, previous problem, same. Just I want to give one problem for practice purpose. Can you say, in this level, how many groups? Here A group, 2 people becomes 1. I think A by 2 groups are there. Every group cost is 2B. I think 2 cancel, AB is the cost. So this level cost for merging AB. Why? Total elements are AB. A group where every group contain B means what? Total elements are AB. AB elements are previously in the, right, this level. Now after merging they shifted to next level. All elements came. So AB elements came. How many groups in this level? Previously groups A group. Now A by 2 groups. Groups are compressed. Groups are, right, minimized. I want one group. I want one group. Slowly I am going. So finally AB elements came. Cost is AB. Once again same way. It will become 4B. Same way here. Don't bother small thing 4b. So what is the answer now? If you merge 2 as 1, again half will become a by 2 square into, right? What is the answer? 2 square b. 4 means 2 square b. I think 2 square cancel, ab again. I think first level, second level same means series not coming, same coming, right? 2 times if I do a by 2 square, 1 time if I do a by 2 power 1, can you help me now? If you do k time, roughly, if you do k time, isn't that if you do k time, one group came, then what is the answer? If you do k time, right, a by 2 power k will come into 2 power k b. I think 2 power k cancel a b there. Now some people are asking, sir, what is that k value? You know. What is the answer? How to find out k value? If you do k time, this story. If you do k time, a by 2 power k groups there. See, a by 2 power k groups came after doing k time. It should be 1. That is the reason I stopped. Otherwise, why I will stop. So, a is equal to 2 power k. Next one, log a base 2 is equal to k. K is log a base 2. Log a base 2. K is log a base 2. Right? Every level cost is ab. So, can you say what is the total cost? What is the answer? ab into log a base 2 big O of, right, this is the time complexity. Every level cost ab, number of levels are log a base 2, total cost is ab log a. Some people are asking one small line. What they are asking is, right, why log a levels came? If you divide a elements are, a groups are there in the first level. If you divide a always by 2, right, definitely log a levels. Every level cost ab log a. This problem, previous problem, same, right? Please take care. Let's see another problem. Please see this problem also you know. Read it once. This problem also you know. Please read it once. How much time it will take to convert n elements array into log n sorted subarrays each of size n by log n? This problem answer you know very well. Read it once. It looks like complex, but it is nothing there. How much time it will take to convert n elements array? What is the input? To convert the n elements array into log n sorted subarrays, each of size n by log n. Can you help me now? To this problem, what is the input? N elements array. What the output is expecting? Log n sorted subarrays, each of size n by log n is expecting. Right? I think this is going to be, this problem already almost we done. Now we will see once again anyhow. See this one. I think n elements array is the input. Output is going to be log n sorted subarrays, each of size n by log n. Each of size n by log n. Right? Let's see. Let's see this. Right? You only say n elements are there. If you divide n elements into, log n groups, log n group, right? Every group size is going to be n by log n. What is there in that? N elements group, the n elements are there. If you divide the n elements into log n group, n by log n is each size. Otherwise, let me ask you, 100 elements you have. If you divide 100 elements into 5 groups, 100 by 5, 20. Every group contains 20 elements. So, this n by log n may not be that much important because indirectly same meaning. 100 elements are there. If I divide into 5 groups, 100 by 5, 20. One group contains 20 elements. This one everyone know that. Right? So, here major story is going to be n elements array if I give, you have to convert into log n sorted subarrays, each of size n by log n. How? How much time it is? I will explain. See the answer. You know very well also this is the answer for this. Can you say how many elements are there? N elements. See this one? N elements. One element, 2 element, 3 element, 4 element, 5. Right? In the place of 5, let me write n minus 1. N, see this one. So, n elements array there, which is nothing but n groups are there, where every group contain one element, same meaning. N elements array is nothing but n groups, where every group is sorted, n groups, where every group sorted, and that group contain one element. One element there, that means sorted only, one element only there. That one means one element. N groups there, where every group contain one element, because of one element sorted only. So, I have now n sorted subarrays, each of size 1. I have now n sorted subarrays, each of size n. That is the input. Input is going to be n elements array, which is nothing but n sorted subarrays, each of size 1. Right? Now what you want? Log n sorted subarrays you want. I think same. What will you do? Just merge two people. If you merge now, groups will be decreased. Now I have n groups. Now after this n by 2 group, if you merge 1, 1, I think 2 elements. 2 elements. 2 elements like that. Can you help me now? How many groups now? Previously n group, now n by 2 group. Right? Every group contains 2 elements. So n time. Previously in this level n element, now also in this level n element. But groups are decreased. Previously groups here n, now here n by 2. But elements in the first level is n, next level also n only. But groups in the first level n, second level n by 2. Right? In the similar way, right, these are sorted. Let's merge again. 2 becomes 4. Right, same story. What is the answer? N by 2 square into 2 square, which will goes to again n. Right, continuous is one. Continue k time. If you continue k time, you only say, if you continue k time, right, if you continue k time, you just say one small line. What is the answer? If you do 2 time n by 2 square, if you do 1 time n by 2 power 1, if you do k time, what is the answer? N by 2 power k groups will come, where every group size is going to be 2 power k. This is also becomes n. So if you do 1 time n by 2, if you do 2 times n by 2 square, 3 times n by 2 cube, if you do k time n by 2 power k. So n by 2 power k, right, n by 2 power k groups there, where every group size is going to be 2 power k, 2 power k, 2 power k, cancel n. Now can you help me now? What is the k value? What is the k value? I want answer from you. What is the k value? What is the answer? You know very well. The k value, see this one. How many groups there in the last level? N by 2 power. N by 2 power k groups are there in the last level. Still I stopped. Why? This value becomes log n, because I want log n sorted subarrays. Yes. Here n sorted subarrays, here n by 2 sorted subarrays, here log n by, see here n by 2 power k sorted subarrays, which is equal to log n. So n is equal to log n into 2 power k. Right? N is equal to log n into 2 power k. Now apply log both the side. Log n is equal to log n, right? Log n plus k, which will goes to, what is the name? Log n minus log n is equal to k. K is this. Log n minus log n. K is equal to log n minus log n. Right? These many levels. Check properly. This problem and previous two problems same. The only little bit changes are there. Can you help me now? After doing k time, how many groups came? N by 2 power k group. After doing 1 time, n by 2. After doing 2 time, n by 2 square. After doing k time, n by 2 power k groups there. But still why you stopped? N by 2 power k becomes log n, because you want log n. So finally n by 2 power k is equal to log n is equal to 2 power k into log n. If you apply log both the side, this is I think log mn formula. Log n is equal to log of mn, means log m plus log n. So log n plus log 2 power k means k. K becomes log n minus log n. So I think problem is over. Can you help me now? What is every level cost? N. How many levels there? Log n minus log n. These many levels. What is every level cost? Right, n. Final answer if you observe. What is the final answer? I think everyone log n minus log n, which is bigger, log n. Final answer is approximately n log n. Approximately n log n. This is the time complexity. Actually log n minus log n into n, which is nothing but n log n minus n log n. Right? Dominator asymptotically, mathematically both are not equal, asymptotically. Yeah, right? N log n. To this problem, answer is going to be n log n. This problem and previous problem same. If anyone disturbed little bit also, all three are same. Please go through it once. I want to show to you how problems look like. That is the reason 3 examples, similar examples I given. Let's go to the next problem. Merge sort algorithm, 3 examples are over. Let's see the 4th example. Merge sort algorithm, see the 4th example. Right, read this. Consider the following array. Some one array is given. Consider the following array. one array is given. How many elements are there in this array? Please check. 3, I think 5, 8, 2. I think 10 elements are there. This array contains 10 elements. Next one. What will be the output after second pass of the straight two-way merge sort algorithm? Here there is no time complexity, is asking output. What will be the output after second pass of the straight two-way merge sort algorithm? Straight two-way merge sort algorithm over, right? In the second pass, what will be the output they are asking, right? How to solve this problem, I will explain now. How to solve this problem, I will explain. Let me take the array once again. Let me take array. See this? 55, 90, 23, 61, 32, 18, 26, 32, 44, 23. This is the array. Right? This array, if you apply straight two-way merge sort algorithm, after second pass, what will be the output? Can you help me now? What is the name of this algorithm? Name of this algorithm is merge sort or straight two-way merge sort algorithm? Straight two-way merge sort, not merge sort. Merge sort means you know, divide, afterwards, right? Combine, divide, conquer, combine. You know that story. That is called as a merge sort. It is a straight two-way merge sort algorithm. Name itself saying straight two-way. What is the meaning? Directly. Straight means directly. Directly take two elements, merge it. That is the meaning of straight two-way merge sort. No divide, nothing. It is not divide and conquer. Straight two-way merge sort algorithm. Directly take two people, merge it. So what is the answer if you do that? 55, 90. Next, 23, 61. Next, 18, 32. Next, 26, 32. Next, 23, 44. Directly take two people, merge it. Right? So I done that. This is called, right? Can you read the output, whatever you got? Read all of them from left to right. 55, 90, 23, 61, 18, 32, 26, 32, 23, 44. This is output. This is output after first pass. This is output after first pass. This is output after first pass. Straight two-way merge sort algorithm, output after first pass. This is. Once again same, do that. Take two and merge it. If not there, right, copy as it is. That means in the next level, it will be merged with someone. Instead of leaving, right, just copy as it is. Right? Can you just add them? 2 plus 2, 4 elements in the sorted order. What is the answer? 23, 55, 61, 90. Next one, 18, 26, 32, 32. Can you help me one small line? How many 32s are there? 2 32s. Carefully listen one line. Listen, interesting one. It is interesting one. Nice point is came. See everyone. See everyone. 32, 32. How many times? 2 times came. 2 32s there. Can you help me one small line now? When you merge it, these 2 32s will come side by side. 2 32s are there in the sorted array. Those 2 32s will come side by side. That is fine. But one thing. In the input, it is the first 32. It is the second 32 in the input. In the input, it is the first 32. It is the second 32. That is fine. Right? Now see this one. It is the first 32. Just I give the symbol also. A means first 32. Assume it is the second 32. So in the given input, 2 32s are there. First 32 is 32A, second 32 is 32B, right? Can you say when you merge it, 18, 26, 2 32s are there. Which 32 will come first? In the input, whichever 32 came first, that 32 only will come. Next 32 will come. So what is the meaning? Repetitive elements order after sorting will not change. Repetitive elements, I am not asking all elements order. Repetitive elements order will not change after sorting. So if you see in the given array, repetitive elements are 32s, 2 32s are there. In the input, first 32 is 32A, second 32 is 32B. After sorting also, first 32 followed by second 32. This is called as, this particular kind of behavior of sorting algorithm is known as, right, stable sorting algorithm. What is the meaning of stable sorting algorithm? Right, repetitive elements order will not change after sorting is known as stable sorting algorithm. Merge sort is stable sorting algorithm. Please be careful. Merge sort is not in place, but it is stable. What is the meaning of stable? repetitive elements order will not change. It is input contain 32A, 32B, that is the order. Output cannot be 32B, 32A. Same 32A, 32B will be there. Sorting will be done, it's okay. But repetitive elements after sorting side by side will come. But side by side, not whatever order you like. Whatever order they are coming, repetitive elements in the input. In the output also same thing will come. Again I am repeating now. What is the meaning of stable sorting algorithm? Repetitive elements order will not change after sorting is known as stable sorting algorithm. Merge sort is stable sorting algorithm because repetitive elements order will not change after sorting. But quick sort is not stable. Afterwards we will see what is the reason. Right? Fine. Anyhow. So 2 32s are there. Right. First 32 as it is will come. Afterwards second 32. Next one. Merge sort is stable. See this one. 32A, 32B. First 32A came, next 32B. In the output also same order. Between these two people only order we have to check. Because of here no chance is there, keep as it is. This is output after second pass of straight two-way merge sort algorithm. Output after second pass. Right, that is, I am thinking that you are comfortable. He is asking what will be the output after second pass of the straight two-way merge sort algorithm. Here there is no divide. Directly take two people merge. Some people are asking, sir, why not 3? He didn't mention. See, two-way merge sort means 2 I will take. If at all 3-way, 3 I will merge. If you don't say anything, you have the chance of taking anything, right? So if at all you don't give anything, try 2 and see answer matching or not. If not, try 3. Anything is okay. That is the reason is mentioned straight two-way. Fine, it's okay. Let's do one more round. Actually not required. Our answer we already got. So what is the answer? Merge these two also. 18, 23, 26, 32, A, 32B. Next, 55, 61, 90. 23, 44. This is output after third pass. Merge these two also. Right? You will get the final answer. Right? So check yourself. Let me write. If you want, I will do that also. Let me do that. 18, 23, A. If you want, 2 23s are there. 23B, 26, 32A, 32B. Next one is going to be 44, 55, 61, 90. This output after fourth pass. This is called straight two-way merge sort algorithm. So on merge sort, time complexity questions like previous problems like that, right? If at all any numerical problem kind of thing, something like this, right? What is the output after first pass, second pass, like this, right? They don't ask for, right, divide and conquer merge sort. When they say merge sort, means whatever we discussed previously. Straight two-way means like this. Right, numerical problems purpose, they may ask you like this. In one of the previous paper it is there, that is the reason I explained. Time complexity is same, approximately is one, approximately log n levels. Right, time complexity is approximately log n levels because always divide by 2 by 2 by 2. Every level n time. What is the reason? All elements are shifted from one level to another level. Right, see this one here. 2 elements are shifted here, 2 like that. Total how many? 10 elements. 10 times. Here also 10 elements. 10 is what? N. Right, here also 10. So every level contain n time, like that log n, right? Answer is going to be n log n. In the place of n, 10 is there. If you want, you can say 10 into log 10 base 2. Time complex, which will goes to approximately n log n. Time, everything same, right? Straight two-way means like this, no divides, nothing. Suppose someone asks you on this array 10 elements, if you apply merge sort algorithm, what is the answer? First divide into 2 parts. Right, left half, right half. Again this is divided into 2 parts, left half, right half, like that. First to divide, afterwards conquer, afterwards combine. You know very well, that is a normal merge sort. Merge sort means like this, divide, afterwards combine. But straight two-way merge sort, right, like this. Right, fine. So what is the output after second pass? This. First pass is this one, second pass is this one. How many passes? Approximately log n. What is every pass cost? N. So finally time complexity n log n. See the next problem. This is the next problem. This is the next problem. Please read it. This is the next problem. Please read it. I am reading now. What will be the time complexity to sort Fibonacci k elements using Fibonacci merge sort, which is like merge sort algorithm, but division will be done like Fibonacci series. I written roughly one problem there in the previous paper. That problem I want to explain to you. I written roughly. I will explain also. Once again let me read. What will be the time complexity to sort Fibonacci k elements using Fibonacci merge sort, which is like merge sort algorithm, but division will be done like Fibonacci series. Right? The problem is directly like this. Can you help me now? In this problem, which merge sort he is using? In this problem, which merge sort he is using? Fibonacci merge sort. Next one, how many elements you want to sort? What will be the time complexity to sort Fibonacci k element? Fibonacci k element you want to sort. Fibonacci k elements you want to sort using Fibonacci merge sort. That is okay. But he is mentioned little bit about Fibonacci merge sort also. What he is mentioned? Fibonacci merge sort is like merge sort. It is like merge sort. But division will be different. Division is like Fibonacci series. These are the keywords. Now let me repeat. I think problem I read many times. Let me repeat the problem. He is having Fibonacci of k elements. He want to sort those many elements using Fibonacci merge sort. Fibonacci merge sort is like merge sort only, but division only difference. How division? Like Fibonacci series. What is that? I will explain now. Right? I will explain. Right? Let's start. It is a nice problem. It is there in the previous paper. One time I will explain. You will get some idea. See this. See everyone. Interesting answer. Please see this. N Fibonacci of n. N Fibonacci of n. Zero, 1, 2, 3, 4, 5, 6, 7. Right, like this. That's, I think this is the n. I am explaining now. What is the answer of this problem I am explaining? Please carefully listen. Carefully listen. This one. 0, 1, 2, 3 and so on 7. Can you help me now? Right? N value 0. What is the Fibonacci of 0? 0. N value 1. What is the Fibonacci of 1? 1. N value 2. What is the Fibonacci of 2? Fibonacci of 2 is equal to Fibonacci of n minus 1, Fibonacci of n minus 2. Add both. 1. Fibonacci of 3, previous 2. 2. Fibonacci of 4, 3. Fibonacci of 5, 5. Fibonacci of 6, 8. Fibonacci of 7, 13. This is the Fibonacci series. N Fibonacci of n. Now can you help me now? If you see this table and talk, can you say n value 6? What is the Fibonacci of 6? 8. N value 7. What is the Fibonacci of 7? 13. Next one. N value 3. What is the Fibonacci of 3? 2. You know very well. If you are really comfortable, see this one. If you are really comfortable, please listen whatever I am going to say. This is the Fibonacci series. Can you help me now? N value 6. What is the Fibonacci of 6? 8. Now see the answer. Now see the interesting answer. Fibonacci of 6 elements. How many? N value 6. Fibonacci of 6. Fibonacci of 6 elements. How many? 8 elements. Fibonacci of 6 elements means 8 elements. Can anyone help me now? Fibonacci of 6 elements I want to sort means 8 elements I want to sort. Fibonacci of 6 elements I want to sort means 8 elements I want to sort. Using Fibonacci merge sort. 8 elements I want to sort. Instead of saying 8 elements I want to sort, he is saying Fibonacci of 6 elements I want to sort. Can you help me now? Fibonacci of 6 means 8 elements. 8 elements I want to sort. Can you say what the merge sort will do? If you want to sort 8 elements, what the merge sort will do? Right? That 8 will be divided into left 4, right 4. 2 equal parts you will do. Right? Normal merge sort algorithm, 8 elements if you want to sort, right? That 8 will be divided into 4 and 4. Everyone know. That is the normal merge sort division behavior. Right? But here, what he is saying? Here, Fibonacci merge sort is like merge sort, but division is the difference. How division? Fibonacci series manner. Can you help me now? Fibonacci of 6 means 8 elements you want to sort. Normal method will divide into 4 and 4, but he will divide. Fibonacci of 6 means 8 elements, he will divide into. Fibonacci of 5 elements one side, Fibonacci of 4 elements one side. Fibonacci of 6 how many? 8. It will be divided into Fibonacci of 5 one side, Fibonacci of 4 one side. What is the Fibonacci of 5? 5. What is the Fibonacci of 4? 3. What is the Fibonacci of 6? See, 8 elements will be divided into Fibonacci series manner. Like that they divided. It is exactly like merge sort. No other difference. Everything same. But division time, Fibonacci series manner divide. What is the meaning? Fibonacci of 6 is nothing but Fibonacci of 5, Fibonacci of 4. Like that you divide. Don't divide 50-50. Divide like this. I am thinking this is the only difference. Remaining all same. Remaining all same means what? Can you help me now? Left how many elements? 5. Right how many elements? 3. If you combine them, if you merge them, how much time? 5 plus 3. Merging time complexity is nothing but moves only. 5 plus 3 is 8. Everything same except division. Now those people who are having little doubt also, let's check this also. Fibonacci of 5 elements I want to sort. Right? How to divide? Fibonacci of 5 means 5. 5 elements I want to sort. In the normal method 50-50, but here Fibonacci of 4 one side, Fibonacci of 3 another side. Same thing here also. What is the Fibonacci for? 3 one side, 2 other side. What about 3? 2 one side, 1 other side. Can you help me? What about 2? 1 and 0. Right? Like that. Same thing for other places also. 3 and 2. 2 and 1. Roughly. 1 and 0. 1 and 0. Next one. This is 2 and 1. 2, 1 and 0. 2, 1 and 0. Like that you have to divide. Now next one. Can you help me now? What is the Fibonacci of 4? 3. This is 2. So if you add both, 5k. Merge algorithm. Can you say Fibonacci of 3? 2. Fibonacci of 3 is this one. Right? Fibonacci of 3 how much? 2. Next one. Fibonacci of 2. What is that one? 1. If you add them, 3k. Remaining all will be same. Now if you are really comfortable, can you help me now? Right? First level merging time. First level merging time. See this one? 5 and 3 if you merge. What is the answer? 8. Can you say second level merging time? This is 5. 3 and 2, 5. This is going to be 2 and 1. Right? Which will goes to 3. Total is 8. Every one merging. See this one, how many elements are there? 8 elements. Every level becomes 8. Right? If you want, you can add all of them. Right? 8 will come. Like that. Everywhere 8, 8, 8. Like that. Right? Like this. Can you help me one small line now? How many level tree? How many exact like merge sort normally contain log n level. Every level cost n. Here also every level cost n. What is the n? 8. Every level cost here also n. But in the normal method, because of always you are dividing by 2, by 2, by 2, log n levels will come. But here how many levels? Let me check here. See this one? Fibonacci of 6, Fibonacci of 5, Fibonacci of 4, Fibonacci 3, Fibonacci 2, Fibonacci 1. I think Fibonacci of 6 means 6 levels. Fibonacci 6 means 6 level tree k. Every level cost is Fibonacci of 6 value. What is that? 8. Can you say what is the total cost? Total cost is going to be 6 level. Every level contain 8 cost. This is the total cost. This is the time complexity to find out Fibonacci of 6. Fibonacci of 6 to find out using Fibonacci merge sort. See, I am repeating once again. To sort Fibonacci 6 elements using Fibonacci merge sort, time complexity is this much. Right? Now what is the answer for this one? To sort Fibonacci k elements, time complexity how much? Using Fibonacci merge sort. What is the answer? K level tree will come. K level tree will come. Every level contain Fibonacci of k elements. This will be the time complexity. Fibonacci of k element. to sort time complexity is equal to k into Fibonacci of k. Why? K level tree will come, every level contain Fibonacci of k, which may be 8. K value 6, assume that Fibonacci of k is 8. Now can you help me? What is the difference between this problem and merge sort? Merge sort, right? Always divide by 2 by 2 by 2, log n level. Every level is n. Here also every level is n, 8. But levels are, right? So Fibonacci of k means k levels. Right? Can you help me now? Fibonacci of k, in the place of 6, if I keep k, here k will come. Right? What is this one? Fibonacci of k. It is Fibonacci of k value. Right, like this. And one more thing, see the one more interesting thing. See this one. First level if you add all, 8 came. Second level if you add all, 8 came. Like that everywhere 8 is coming. But when you go to the further levels, you know, here k levels there means this side is k by 2. What is the meaning? Right hand side few things are missing. When you go further, right, this may not be equal to 8. This will be less than 8. Right? That is the reason it is upper bound. Big O. Actual answer is not this much, right? Upper bound I am taken. It is, I see this one. It is a less than 8, but I am taken upper bound, right? When you go further levels, less than 8 will come. But still I am taking 8. That is the reason I can say upper bound. What is the meaning of this line? Time complexity to sort Fibonacci k elements. If you want, I will write. See this one. If you want, I will write. Time complexity to find Fibonacci k elements. Time complexity to sort Fibonacci k elements. Time complexity to sort Fibonacci k elements is equal to k into Fibonacci of k. Check properly if anyone having any small doubt also. Check. Can you say Fibonacci of 6 elements I want to sort using this particular story? How many level? 6 level. What is every level cost? 8. So total cost 6 into 8. Similar way, Fibonacci of k how much? K into Fibonacci of k. So time complexity to sort Fibonacci k element, k into Fibonacci of k. And one more, when you go to below levels, it is not 8, it is less than 8. So upper bound. Right? Please be careful. I am thinking you are okay. Can you help me now? This problem and merge sort difference. Merge sort always divide by 2, but here Fibonacci series manner you divide. It is a nice problem, right? Anyone having any doubt, right? Anyone having any doubt, please see again. Total story. I repeated many times. This is the diagram. This is the explanation for that. Fine. See the next problem on the merge sort. See this. Given two arrays, A, m distinct elements, B, n distinct elements. Two arrays are given A and B. A contain m distinct elements, B contain n distinct elements. What will be the time complexity to compute A intersection B and A union B? To do the A intersection B, A union B, what will be the time complexity they are asking? Right? A don't have repetition, B don't have repetition, but A and B combinedly may be repetition. Means intersection may be there. Right? What is the A union B? What is the A intersection B? We have to compute, right? So I am doing now. So I am starting. Right? Let's do first intersection. If you know intersection, you know union also. So I am starting now. Let me do intersection first. See the answer I am starting? Intersection I am doing. To this problem, how to do intersection, right? I will explain. Can you help me now? Given two arrays, A m distinct elements, B n distinct elements, right? He is asking intersection how much time, union how much time. And one more thing, before going to give answer for this one for intersection, assume that given two sorted arrays, right? Assume that given two sorted arrays. So first let's do for sorted, afterwards I will do unsorted also, nothing there, right? See this one, given two sorted arrays, A, M distinct elements, B, N distinct elements, then what is the intersection? Let me do for sorted, unsorted also I will do. Right? Let's see this. So I am starting, see everyone now. A array, which is sorted. B also, which is sorted. See, let me take some elements also. 10, 20, 30, 40, 50, 60, 70, 80. Some elements. This one. 5, 15, 20, 25, 30, 50, 65, 70, 90, some elements. A is sorted, B also sorted, please check. I want to do intersection, how? Right? Now can you help me? A contain how many elements? M elements. B contain N. Right? Now how to do intersection? Can you help me now? What is the one way? Both are sorted, it's okay. Without sorted also we will do, don't worry. Right? So can you help me now how to solve this problem? This is the way. Intersection means common element. What is the output expected? Can you say what are the common elements? This problem saying that two sorted arrays I given to you, intersection find out means common element. Can you say what is the output expected for this one? I think common elements 20, next. Common elements 30, common elements 50, common elements 70. So I think this is the output expected. What is the output? 20, 30, 50, 70. This is the output expected. Right? How to get that? I will explain that. Mostly you know answer for this problem. I will explain. See, this is the answer for this. To this problem answer is going to be, right? So he is asking how much time, see, what will be the time complexity? If you know the procedure, automatically time complexity will come. So one answer for this problem is going to be, see, one answer. Intersection you want means common element, nothing there. In the A array, see this one, in the A array, right, first person you take, this person will ask every person, I am 10, is there any 10 like that? He will ask everyone. What do you mean? Asking everyone means linear search. He is doing linear search. For the first person, linear search in the B. Anywhere matching, it's okay. Right? Then you will print. Matching not there. Matching not there. It's fine. Right? 10 will ask every person. Is there any matching like me? So that I will print. Anyone is there. Print it. Otherwise, don't print. Same way. 20 also will ask everyone. Worst case. 30 also will ask everyone. Worst case. Can you help me know what is the answer? For every element of A, do linear search in the B. So can you help me know what is the time complexity? Now I am writing. See this one. See the time complexity. To this problem, intersection. To the intersection, right? One answer is going to be, what is the answer? Linear search you can do. How many times? For every element of A, do linear search in the B. In the linear search you are doing in the B array. Please be careful. B array. B array contain how many elements? M and N. So this is the answer. M times linear search on N elements. Because B array contain N elements. On N elements linear search will take N time. So M times you are doing each element of A. Do linear search on the B. So this answer will goes to, what is the answer? M into N. So time complexity order of Mn. Right? So using linear search you can solve this problem. Answer is order of Mn. Right? Fine. Now let's see one more problem. One more thing. See this one. One more thing. See this also. Linear search is the one of the answer for this problem. That's okay. See the one more algorithm. See the one more algorithm. Nice algorithm. See everyone. So previous algorithm, if you see linear search, right? This person asking every person, is there anyone exactly like me like that, right? What he will do is, because of it is already sorted, what he will do is, right? This person don't ask everyone. He will ask middle person, right? I am 10, are you 10 or not? If he say yes, stop. Otherwise, right, he will ask, right? So why are you saying no, right? Comparing you, am I smaller or bigger? If you say comparing me, you are smaller, then go left side, right? Then go left side, right? Suppose he is saying that 10 is asking 50, am I, both are okay? No. He is saying that you are less than me, then go left side. Again ask mid, are you 10? No. He will say less than me, then go left. Next one, right? Are you 10? No. Right? More than me, then go right. Are you 10? No. Right? Only one element, that is not. It means no matching. So for each element of A, do binary search on B. So how much time? Log. Right? Let's see this one. 2 second algorithm is going to be M times do linear, right, in the place of linear search, binary search on n elements. Binary search on n elements is going to be log n, so m times log n, finally answer is going to be m log n, right? Fine. Suppose m is equal to n, this will become n square, this will become n log n. If at all both are equal, it will become n log n, right? So first algorithm is going to be using linear search, second algorithm using binary search. So this is n square, forget about m and n, this is n square, this is n log n better, right? See the one more interesting answer. It will trouble you if you don't listen. The basic purpose of giving this problem, the thing which I am going to explain now, third algorithm is important. Please be careful. I am starting. See the answer. How to solve this problem better way, right? There is one more nice algorithm there. I am starting now. See the starting algorithm. Listen, do you know merge algorithm? Can you see what is the merge algorithm? If you apply the merge algorithm on the two sorted arrays, what the merge algorithm will do? Compare both the first element, whichever smaller take, everyone know. Merge algorithm, you know, first group first element, second group first element, both compare. Whichever smaller take, that is the merge algorithm. Same merge algorithm you can apply here. Some people are asking how. And one more, merge algorithm time complexity how much? Merge algorithm time complexity how much? Everyone know. What is the answer? All elements are moving, m plus n. Right? Now here, merge algorithm you can apply, right? We will see how it is. See answer. Interesting one. Merge algorithm I am applying now. See the answer. Is first one is sorted? Yes. Is second one is sorted? Yes. Both are sorted. See the merge algorithm. Right? So compare both the first persons. See everyone now. Compare both the first person. Yes, I compared. When you compare both the first person, see, is both the first persons, if both are equal, then print it. If not equal, don't print it. Because in the intersection, you are doing intersection using merge algorithm. To find out intersection, I am using merge algorithm. How? Let's see. Merge algorithm input two sorted subarrays. Yes. Intersection means common elements only print. Now I am starting. Can you help me now? Both the first elements compare. Both are equal. No. Who is smaller? 5. Whoever smaller, cancel it. Don't print. Same merge algorithm. In the merge algorithm, smaller one print. Now smaller one cancel. That's it. Next one again. 10 and 15 compare. Both are equal. No. Smaller one cancel. Next one. 20, 15 compare. Both are equal. No. Smaller one cancel. Next one. 20, 20 compare. Yes. If it is equal, print it. Then after printing, cancel both. Some people are asking, sir, how to cancel both? I plus plus, j plus plus, what is there? If it is only one, I plus plus. Only one, j plus plus. If both equal, print one time, right? Then increment both, I plus plus, j plus plus, nothing there. Now again, now see this one. 30, 25, small, right? Equal, no. Smaller one, skip it. 30, 30 equal, then print one time, right? Skip both. Next one, 40, 50, smaller one, skip it. 50, 50, print one time, skip both. Next one, 60, 65, smaller one, skip it. 70, 65, let me delete this. See, 70, 65, smaller one, skip it. 70, 70, yes, skip both. Next one, 80, 90, smaller one, skip. And one more thing, when one group is over, stop it, because now we are not doing here merge. We are using merge algorithm to do intersection. Whenever one group is over, where is the chance of common elements? Same merge algorithm. Merge algorithm, smaller print. But here, what is the answer? Smaller skip. But in the case of the merge algorithm, equal, what will you do? In the case of merge algorithm, equal, what will you do? Print both. Merge algorithm means all required. Left contain m people, right contain n people. Merge algorithm saying that I want all in sorted order. And one more, merge sort is stable. What is the meaning? If two people equal, take both, but first one first, second one second. That is the meaning of merge algorithm stable. In merge algorithm, equal people two coming, take both, but here, equal people coming. Take one, skip both. Now can we repeat now? Merge algorithm, this one. Same merge algorithm I am using for intersection, right? Can you help me? If you do only merge algorithm, forget about intersection. What is the procedure? Smaller print, smaller print, smaller print, equal, print both and skip both. Merge algorithm I am talking, only merge. Smaller print, equal, print both, skip both. But in this one, same merge algorithm logic, in this one, what will you do? Smaller, skip, because I want equal only. Smaller, skip, equal, print one, any one, skip both. This is the logic. Now because of you are doing only one scan, merge algorithm, m plus n time. M plus n time, nothing there, m plus n time, right? Let me write now. Third algorithm, see this one, third algorithm. What is it? Merge algorithm you can do. Merge algorithm apply. Right? Merge algorithm time complexity. What is the answer? Order of m plus n. If both are equal, what is the time complexity? Right? N plus n, n time. So first algorithm n squared, second algorithm n log n. If both are equal, m and n both are equal. First one n squared, second one n log n, third one n. This is the best algorithm. To say this only, I given this problem. To say this only, I given this problem. Right? I am thinking you are okay. Next one, can you help me? This problem, intersection you are doing. This is for sorted array or unsorted array. Right? Let me ask you. See this one. Right? A intersection B for sorted. Can you help me? Which is the best answer? I want to find out A intersection B in given two sorted arrays. Three algorithms are there, it's okay. Best algorithm, this one. This only our goal. These two things you can cancel. For sorted, this is the answer. Some people are asking, same problem, for unsorted, what is the answer? Same problem, intersection only, unsorted arrays, what is the answer? Right? Can you apply the third algorithm directly? No. If you want to apply merge algorithm, both should be sorted. That is the reason. Unsorted, first step, sort. Using merge sort. How much time? N log n. Second one, apply merge algorithm. Apply merge algorithm. Merge algorithm, how much? N. Overall n log n. First to sort, then merge algorithm, n log n. So same story, how to do union. Same story, how to do union. See this one, A union B I want to do. Right? A union B I want to do. Right? Assume that sorted. A union B sorted. How it is? Right? See first one. Please verify yourself. First one, linear search possible. N square. Same thing like whatever we done for intersection, union also same story. Please verify yourself. Binary search also possible. N log n. Right? See the third one, merge algorithm possible. Right? Answer is going to be n, m plus n. If both are equal, n plus n, n. How it is, right? These two you know very well. Just one time you check. See the third one, how merge algorithm for union. So sorted, this is the story, right? So how it is. See everyone. So before going to this problem, let me check here. Merge algorithm. Can you help me? Merge algorithm. Two elements, both the first elements compare. Smaller print, equal. What the merge algorithm will do? Merge algorithm means I want all. Smaller take, equal, take both. Right? Smaller take, equal, take both. That is the merge algorithm. But see the union now. See the union now. Union, merge algorithm almost similar. One small minor change there. See this one. Right? So I am starting. Compare both. Right? Compare both. I am comparing. So when you compare smaller one, right? See this one. When you compare smaller one, take. See this one. Merge, when you say union, all should come. Union means all should come. Merge also all should come. Union also all should come. Please be careful. Can you help me? 10-5 smaller print. Next one. 10-15 smaller print. Union means all required. Merge also all required, but minute difference is there. See this one. 10-5, 5 smaller print. 10-15, 10 smaller print. 15-20, smaller 15 print. 20-20, see the interesting answer. 20-20, both are equal. In the case of merge algorithm, print both. But in the case of the union, print one person, skip both. This is the only difference. Merge also, everything print, right? Union also, everything print. But in the union, same thing cannot be printed twice, one time only. Merge means all required. One element also cannot miss. That is the meaning of merge. In the case of union, same thing cannot come twice. Right? Again I am repeating now. See this one. 30-25, smaller print. Next one 30-30, right? Because of it the union, right? Take one person, skip both. But merge algorithm, take both. First one first, second one second. Right? But here take only one. Next one 40-50, smaller print. 50-50, print one person, skip both. Next one 60-65, smaller one print. 70-65, smaller one print. 70-70, print one time, skip both. Next one 80-90, smaller one print. Can help in whenever one group is over, remaining group elements copy as it is. It is almost like exactly merge algorithm. Exactly merge. Where differ? Both equal. Merge algorithm print both, but union print one. So time complex same, exactly same, no other change also. Right? Intersection at least. What is the intersection? Intersection saying that common only print. Smaller, skip it, don't print. Smaller, skip it, don't print. Equal, print one time, skip both. Merge algorithm only, little bit modification. This is called modified merge algorithm. Using merge algorithm, by doing small changes, you will get the answer. Right? So whatever you done for the union, whatever you done for intersection, union also same. A union B, sorted, both three algorithms possible. This is the best algorithm. This is the best algorithm. Right? This only for namesake I said to you. This is the best. So from today onwards, if anyone asks you, merging, see this one, from today onwards, if anyone asks you, two sorted arrays if you want to do union, two sorted arrays if you want to do union, right? Apply merge algorithm, answer is n plus n, m plus n or n plus n, which is nothing but n. This is for sorted. Can you help me now? Same story for unsorted. For unsorted, what is the first step? Sort. What is the second step? Merge. Right? Finally, answer is going to be sorting is n log n, merging is n, so n log n. Intersection also same story, union also same story. Let me compress it. Right? This is given two sorted arrays A and B, which contain m elements, m distinct element, m and n distinct element, that is fine. So union, I think union I explained there. Right? It is the intersection. Right? It is the intersection, that is the union. If you get any one, indirectly, directly, merge algorithm I explained. Can help you to solve this problem. Sorted, what is the answer? N. Unsorted, what is the answer? Unsorted, what is the answer? N log n. If you want to talk in terms of m and n, sorted, what is the answer? M plus n. Unsorted, what is the answer? First to sort. Both the things you have to sort. Right? I think both the things sorting. First one sorting m log m, second one sorting n log n, plus next story. Right? M and n different. If both are equal, nothing there. Right? That is the answer for this. Fine. See the last problem of merge sort. See last problem of merge sort, which is a nice problem. Right? Please read it. I written roughly. Right? If you want, I will read it. Right? If you want, I will read it. I am reading. See. What will be the worst case time complexity? What will be the worst case time? This one. What will be the worst case time complexity? To convert log n subarrays, each of size n by log n into sorted array with n elements. Log n subarrays, each of size n by log n means how many? N. Right? So what will be the worst case time complexity to convert log n subarrays each of size n by log n into sorted array with n elements? So is having log n subarrays, each of size n by log n. You want to make it as single sorted array with n elements. Some people are thinking that, sir, this problem you already covered. Why are you covering again? No, you are misunderstanding. Right? Read the problem again. This one I didn't cover. Major point is missing. Right? See this one. First problem is this only. But there is a big difference. Right? Let's check here. Repeat again. What will be the worst case time complexity to convert log n subarrays each of size n by log n into sorted array with n elements? Right? So this problem, first problem looking like same, but in the first problem if you observe, log n sorted subarrays, but here log n subarrays, log n sorted subarrays in the first problem, but here log n subarrays means subarrays are not sorted. In the first problem they sorted, but here they are not sorted. Right? Please be careful, this is the difference. Everything same, this is the difference. Right? Now let me explain. See this one. So let me explain. Please be careful this also. First subarray, second subarray, third one, fourth one, and so on. Right? Like log n subarrays are there. First, second, third, fourth, log n minus 1, log n. Right? These many subarrays. Can you help me now? Every subarray contains how many elements? N by log n. N by log n. N by log n, right, like this. Right, these many subarray, but one thing, these are not sorted. Previously they sorted, now they are not sorted. Right, now see the interesting answer. Log n subarrays are there, each of size n by log n. You want to make it as single sorted array, that is also okay. Everything is absolutely fine, everything absolutely fine. First problem, not previous problem also. First problem, this problem same, but these are not sorted, but they are sorted there. Some people are asking, sir, what is there in that? Merge it. Right? What is there in that? Merge. If you want to merge, they should be sorted. If you want to merge them, they should be sorted, then only you can merge. Otherwise you cannot merge. You have log n subarrays, not sorted subarrays. So without sorting those, right? How will you merge? Merge algorithm you know very well. Merge algorithm required more than one sorted subarray. More than one. Minimum 2 required to merge. So because of they are not sorted, you cannot merge. Some people are asking, then what I have to do now? See the problem again. See the problem. See this? See the problem? What will be the worst case time complexity to convert log n subarrays each of size n by log n into sorted array with n elements? That's okay. Some people are asking, sir, they are not, subarrays are not sorted, then what we have to do? We cannot merge also. He is given a hint. See this one. You got to know problem. What is the problem? Subarrays are not sorted. Then how can I merge? He is given a hint also. See the hint here. Hint is saying that log n subarrays each are sorted individually using insertion sort. Log n subarrays each are sorted individually using insertion sort. Right? I think he is given the answer. Is given answer, right? So log n subarrays each of size n by log n, it's okay, right? So if I want to merge, they should be sorted. I have to merge because I have to make single. If I want to merge, right, compulsory they should be sorted. They are not sorted, but he is given a hint. What is the hint? Using insertion sort, they sorted. Using insertion sort. Can you help me now? If anyone knows insertion sort, right, in the coming classes I will cover insertion sort also, right? Try to remember insertion sort algorithm, n element to sort. Insertion sort algorithm worst case will take n square. N element to sort using insertion sort, it will take n square. Merge sort will take n log n only. Quick sort also will take n log n. Sometimes quick sort will take n square, it's okay, right? After merge sort over, next quick sort only, don't worry. Now again I am asking you, can you say what is the hint given? To sort these subarrays is using insertion sort. Insertion sort worst case will take n square. Please be careful. He is applying insertion sort algorithm individually is applying. So what is the meaning? On this also insertion sort he will apply and he will sort. Here also insertion sort he will apply and he will sort. Can you help me one small line now? You only say in this level, right? How many groups there? Log n groups. Can you say every group contain how many elements? N by log n. If every group contain n by log n, please see this one, n elements are there, insertion sort will take worst case n square. N by log n elements are there, insertion sort will take n by log n square. So to sort these people n by log n square, to sort these people n by log n square, like that how many time? Log n time. Right? Now simplify this. If you simplify, it will become log n cancel, it will become n square by log n. N square by log n. It is the log n square, it is only log n, right? Both I think cancel, n square by log n will be there. Now some people are asking, sir, everyone is now sorted. After this much time is over, everyone is sorted. Now normal. What is the normal? Combine it. This will become normal. Can you help me? If you combine, what is the answer? It will become 2n by log n. This is also 2n by log n. This is also 2n by log n. Can you help me? How much time this is? How much time? Log n by 2 groups. Every group size is going to be 2n by log n. Both cancel, log n 2 to n is there. Right? Like that every level is n. If you want, you can do next level also. You know this, we are already done. Right? This level also. What is the answer? Log n by 2 square into 2 square n by log n. Log n cancel, 2 square cancel, again n. It will continue like this. How many times? N, like that. How many times? Log n always you are dividing by 2, by 2, by 2. What is the answer? Log n. So everywhere n, like that log n time, it will become n log n. Right? So what is the final answer? This one plus this story. Overall, what is the answer? This is the overall answer. Can you help me now? Bottom level cost, n square by log n. Remaining level cost, n log n. N log n. Right? Other than this, nothing. This. Can you say which one is the bigger? Which one is bigger? I think it is going to be n square. This is the bigger one. This is only n there. Here only n there. It is n square there. N square there. So this is the bigger one. If you don't know, if you don't want to take risk, just keep big O. N square by log n plus n log n. You know here n is there, but here n square. Bigger one is this only. Right? If you want, you can write like this also. Big O of n square by log n. This is the final answer. Everything is okay. What is the only thing? Right? So sub problems are not sorted. He is given the hint also how to sort. He is given hint. Log n subarrays each are sorted individually using insertion sort. He is given the hint. Because of he is given insertion sort, I am taking insertion sort. If you don't give, I may take some better algorithm. Which may be better? Merge sort I will take. I may take merge sort, which will take n log n. Whichever will take less time, I will take. Because of he is given hint to, I have to go there. Right? So to this problem, final answer is going to be just add. Right? Just add bottom level cost, this one. Bottom level cost is going to be, right? If you see the simplification, this is the bottom level cost. Right? Previous, right? Remaining levels are n log n. You know this already. N square by log n plus n log n. Finally, n square by log n. Whichever is bigger is the answer. It is n into log n. But it is going to be n square by log n. If anyone thinking that small doubt also there, sir, which one is smaller, which one is bigger, I have some doubt. If anyone having, just apply log, you will get the clarity. Apply log, you will get the clarity. Right? Please be careful. Final answer is going to be big O of n square log n. This is the only extra. This is the only extra. Right? Fine. Now see, so many problems I said to you about merge sort algorithm. So many. But by seeing all problem, you will get to know one thing. What is that? Basics only you will ask. How much strong you are in the basics. Those only you will ask. Do you believe or not? This is the combination of. This is the combination of merge algorithm also and do you know insertion sort or not? Right? Sometimes he will ask, right? Merge algorithm also, merge sort. Right? Sorry. Merge algorithm also and bubble sort. Merge algorithm also, selection sort. So all sorting techniques, two sorting algorithms he may combine. But one thing, basics only. Out of syllabus he never asked. Whatever questions I asked you, these are the things which are given in the previous paper. They don't ask out of the syllabus. Two sorting algorithm you will mix. I think if you see one problem, Fibonacci series, merge sort he mixed. Here, right, insertion sort and merge algorithm he mixed. Right? You see all of them. Right? I think asking, testing basics, are you really strong? Are you by-hearted? Are you by-hearted the total time complexity of the merge sort? Are you done meaningfully? If you do meaningfully, you have to give answers for these also. Okay, whatever you got or not, it doesn't matter. Just once again revise. Whatever possible I tried, whatever possible you tried, right? Just revise again. Everything is, try to remember, some people are, you have to understand this one. Some people are cracking IAS. Some people are cracking, right, IAS exam without taking coaching, without taking any guidance. They are cracking, right? If you go to the villages, Some people are cracking IAS without taking coaching. After listening this much, if you don't get, right, nothing, they just revise again.